Lesson 10, Part 1 of Elements of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Amy Gramour. Elements of Geology by William Ruschenberger. Lesson 10, Part 1. Classification of formations. Different kinds of stratification. Dip, strike, conformable stratification, unconformable stratification, false stratification, the form and habits of an animal deducible from a single bone, relative ages of the principal catastrophes of the globe, systems of upheaval, classification of, state of Europe at different epochs of formation, deluge, geogeny. Classification of formations. As already mentioned, the several formations are divided into two classes, namely, first, massive or igneous formations, which are produced by the action of fire and are not stratified. The terms primitive and transition have been applied to these formations, but, as they are inexact, they are going out of use. Second, sedimentary formations, which are deposited by the action of water and are stratified. Massive or igneous formations escaped from the earth in a state of fusion and became solid by cooling, but without being stratified. They are divided into two classes. First, those crystalline rocks which are not traceable to the crater or any volcano now recognizable, such as granite, trachyte, etc. Second, massive rocks of a slightly crystalline structure traceable to volcanoes, such as modern and ancient lavas and basaltic formations. Sedimentary formations are arranged according to their relative antiquity. They are divided into groups, composed of those which appear to have been formed either at the same epoch or during a geological period, during which the general condition of the earth appears to have undergone no important change. These formations are commonly divided into 5 groups, namely, first, primary stratified rocks, in which neither organic remains nor fragments of the most ancient rocks are found. This group includes gneiss, mica schist, quartz, transition limestone, and argillaceous schist. Second, the transition formations, which rest on the primary stratified rocks and contain fossils of plants or animals, but which appear to have been deposited prior to the creation of the most perfect beings of either kingdom, and only contain the remains of aquatic animals, which are all very different from those of our times, such as trilobites. This group includes fossiliferous schists, transition limestones, etc. Third, the secondary formations were deposited at periods less remote than the transition, and consequently rest on beds of the latter, or on primary rocks, but they go back to a time when the state of the globe was very different from its present condition. Very few mammals then existed. Ammonites are among the most characteristic fossils of the secondary formation. The secondary formations are subdivided into, first, the Carboniferous, which includes old red sandstone, mountain limestone, and coal. Second, the Siliferous, embracing new red sandstone, muschelkalk, and variegated marls, forming the Triassic system. Third, the Jurassic, embracing the Liaskic, the Oolite, the Wealden groups. Fourth, the Cretaceous, embracing the lower greensand, Gault, upper greensand, chalk marl, chalk without, and chalk with flints. Fourth, the Tertiary formations, which, being more recent, covered all the preceding formations. They date from a period when animals and plants belonging to all the great classes existed, but still anterior to the creation of man. The Tertiaries are subdivided into 3 groups. First, the older Tertiary or Eocene, which embraces the London clay, Bagshot sand, and Paris basin. Second, the middle Tertiary or Miocene, which embraces the coralline crag, red crag, and molasse of Switzerland, etc. Third, the newer Tertiary or Pliocene, which embraces Norwich crag, the sub-Apennine beds, the brown coal of Germany, etc., as well as the superficial deposits called Pleistocene, consisting of diluvium and alluvium. Fifth, the modern formations, which are contemporaneous with the existence of man on the earth and are still being formed. The subdivisions embrace, first, peat bogs formed by the accumulation of the debris of certain plants. Second, coral formations from the multiplication of polyparea, as seen in the coral islands of the Pacific. Third, concretiary formations, formed by calcareous and other matters, found in solution in the waters of certain springs, etc., as travertine, stalactites, stalagmites, etc. Fourth, formations from transport or drift, as fluviatile, terrestrial or marine alluvions, dunes, etc. Fifth, humus, or vegetable earth, formed directly by the disintegration of other formations, and their mixture with the products of decomposition of plants and animals, spread in a layer of more or less thickness on almost every point of the earth's surface. All these deposits are superposed one on the other, in a constant order, and if it were possible to make a sufficient section in a part of the globe where they all exist together, we should find a succession of 27 stories or layers, distinguishable by their different characters. But each of the great deposits is divided and subdivided into various layers, more or less distinct, composed most frequently of arenicious substances, clay and limestone, of different degrees of consistence, and beds of varying thickness. The assemblage of their alternate beds often forms successive layers, several hundred yards thick. It is evident that if such sections existed in the crust of the earth, we could see all the beds, and easily distinguish their relative ages by their number in the order of succession, the deepest being the most ancient, and that forming the surface being the most modern. It would then be sufficient, in sections of different depths, which would be found elsewhere, to count from above downwards, to know always where we were, and even the variations that a determinate bed might undergo in different places would offer no difficulty to observation. But such is not the case. The numerous escarpments we meet always present us with but a very small portion of the series, sometimes in one part of its thickness, and sometimes in another. We never see the entire series, and it is only by combining the observations made in different places that we have been able to establish what we now know. At the same time we discovered the particular circumstances of formation of each deposit. In consequence of the divisions of the whole, it is conceived, it might become very difficult to distinguish them, and that in presence of an escarpment one might frequently be unable, at first sight, to decide on the point in the series to which it ought to be referred. Indeed, different beds of the same nature, which succeed each other in the series, are often very analogous, the limestones of one story more or less resembling those of another, and the same is true of different deposits of sandstone and clay. It also happens that the same deposit varies at different points. Here it is a compact, and there an earthy limestone. In another place the same limestone is found mixed with sands, and further on it is nearly pure sand, etc. The injection of crystalline matter adds to the embarrassment, by the modifications it causes in the texture, and even in the nature of everything in its vicinity. It is also conceived that the fewer the beds superposed in the same place, the greater the difficulties, and they are at a maximum when we meet an isolated deposit, without knowing on what it rests, and not being able to perceive anything it covers. This occurs in a great many countries. It often happens, too, that one or more beds are entirely wanting in one locality, and then the deposits which should naturally separate them, being immediately superposed, exposes the observer to attribute to the succeeding beds an age very different from that which really belongs to them. To obviate this difficulty, we have observations on the continuity of beds, some of which we can follow from points where they present certain characters, to others where they offer different characters, from points where they are entirely isolated, to others where we can see on what they rest, and what covers them, etc. We have also observations on stratification and inclination of different beds towards one point or the other, which enable us to infer that such a species of deposit passes below or above another, found isolated or at a distance. Fragments and rolled flints may evidently indicate the priority of deposits which contain them, to those from which they came, and thus furnish a good means of distinction when they are sufficiently characterized. and the nature of organic remains has now become a very decided aid in distinguishing different formations. Different kinds of stratification. There are two kinds of stratification: one horizontal, which is the natural stratification, according to which all transported matters are deposited under water; the other more or less inclined, resulting from upheavals which have taken place at different epochs. In the latter we distinguish the degree of inclination or dip, which may be vertical, and the point of the horizon towards which the beds dip. The last part of the observation determines the direction of the crests of the strata, or, as we say, the strike, or direction of the strata, which is always at right angles to the dip, or direction of the inclination, and which also indicates the direction of the movement by which the effect was produced. But the first observation of horizontal or inclined strata is not always sufficient. It is frequently necessary to distinguish the relative stratification of different deposits, which is reduced to the concordance or the discordance which may exist between them. The dip of strata is the point of the compass towards which they slope, while the angle they form with the plane of the horizon is called the angle of dip. The term dip refers to the inclination of a stratum, and the term strike is used to express its direction. Thus strata may dip to the north at an angle of 45 degrees. In this case the strike or line of bearing must necessarily be east and west, because the strike is always at right angles with the dip. Dip and strike may be aptly illustrated by a row of houses running east and west, the long ridge of the roof representing the strike of the stratum of slates, which dip on one side to the north and on the other to the south. The angle formed by the roof with the plane of the horizon would be the angle of dip. Conformable stratification. When all the strata of a formation are parallel to each other, that is, when there is a concordance between them, whatever may be their general position, horizontal or inclined, convex or concave, they are said to be conformable. Unconformable stratification. When the strata of a formation are not parallel to each other, when there is a discordance between them, as where horizontal strata come in contact with inclined beds, or where the relative inclination of beds is different, they are said to be unconformable. Where a superior deposit, whether stratified or not, rests on a section of the beds of an inferior deposit, there is a peculiar kind of unconformable stratification, sometimes called transgressive stratification. There is another kind of unconformable stratification where the beds are parallel. This occurs where a horizontal deposit, after being furrowed in different ways by water, is again entirely covered by a deposit of the same nature, which fills up all the excavations. In this case the strata are unconformable where they join end to end with beds on the slope of ancient valleys. To ascertain the relations in the stratification of two deposits, it is necessary to pay great attention to the particular structure of the beds, which in certain cases may lead us into error. For example, seeing that the divisions of the bed A dip towards the left of the figure, we must not conclude that the stratification is unconformable with the bed B. This appearance results altogether from the structure which the bed A owes to its rapid formation under particular circumstances. Schistose substances often present many difficulties in this respect, because their divisions run in every direction, and sometimes the least apparent is the real stratification. For instance, we might suppose the deposit A rested conformably on the deposit B, and that the mass C is an unconformable stratification from regarding the finest divisions of the schist as indicative of the stratification. But we might also consider the deposit A as unconformable and the deposit C as conformable from regarding the parallel joints I to K as those of stratification, and it is possible to view both A and C as unconformable relative to B, by considering the other joints as those of the strata. It may be often difficult to decide. Nevertheless, in general, the schistose division is frequently a structure which has perhaps a certain crystallization of micaceous matter, and it is this character, therefore, among others, that we must ordinarily select. Now the joints of dislocation, for one or the other division must have been thus produced, are splits united and well marked, often a little open, which are ordinarily prolonged into several consecutive deposits, while the joints of stratification are more undulated and more adherent. The most irregular undulations of true strata are often traversed throughout by the schistose structure, without alteration. This circumstance evidently shows that this structure is in effect posterior to the contortion of the beds, and may be attributed to a metamorphism more modern than their derangement. The extraordinary divisions just mentioned are sometimes termed false stratification. End of Part 1 of Lesson 10. Lesson 10, Part 2 of Elements of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Elements of Geology by William Ruschenberger. Lesson 10, Part 2. Organic remains, which are very numerous in most sedimentary deposits, also furnish a means of recognizing strata. There are some which are peculiar to certain deposits, and are not found elsewhere, and which are therefore distinguished as geognostic horizons. Thus the Silurian or Devonian formations are clearly recognized by the presence of the remains of a certain family of crustaceans named trilobites. The Gryphea arcuata is found in the lias, and only in it. The Exogyra verdula belongs to the upper part of the Jurassic formation. Baculites and Turrilites begin and end in the Cretaceous period. Although the remains of mollusks and small animals are found entire, and therefore easily recognized, those of large mammals, etc., often exist only in fragments, and without the necessary knowledge, the family, genus, or species could not be discovered. But those well acquainted with comparative anatomy, and the laws which govern in the organization of animals, can deduce the form and even the habits of an animal often from a single bone. Quote, "Every organized being may be considered as an entire and perfect system, of which all the different parts mutually correspond, and concur in the same definitive action by a reciprocal reaction. No one part can undergo a change without a corresponding change taking place in all the others, and consequently each part, taken separately, indicates and gives the key to a knowledge of all the rest. Thus, if the stomach of an animal is so organized as only to digest fresh animal food, its jaws must also be so contrived as to devour such prey, its claws to seize and tear it, its teeth to cut and divide it, the whole structure of its locomotive organs to pursue and obtain it, its organs of sense to perceive it from afar, and nature must have even placed in its brain the necessary instinct to enable it to conceal itself, and to bring its victim within its toils. Such will be the general conditions of a carnivorous animal. They must inevitably be brought together in every species intended to be carnivorous, for its race could not subsist without them. But under these general conditions there exist also special ones, relating to the size, the habits, and the haunts of the prey, on which the animal is to exist. And from each one of these special conditions there result certain modifications, in detail, of the form required by the general conditions, so that not merely the class, but the order, the genus, and even the species, will be found expressed by, and deducible from, the structure of each part. In order, for example, that the jaws may be enabled to seize the prey, there must be a certain shaped prominence for its articulation, a certain relation between the position of the resistance and that of the power, with respect to that of the fulcrum, a certain magnitude of the muscle that works the jaw, requiring corresponding dimensions of the pit in which that muscle is received, and of the convexity of the arch of bone beneath which it passes, while this arch must also possess a certain amount of strength to enable it to bear the strain of another muscle. That the animal may be enabled to carry off its prey, a certain degree of strength is necessary in the muscles which support the head, whence results a peculiar structure in the vertebrae to which these muscles are attached, and in the back of the skull where they are inserted. That the teeth may be adapted to tear flesh, they must be sharp, and they must be more or less so, exactly according as they are likely to have more or less flesh to tear, while their bases must be strong in proportion to the quantity of bone and the magnitude of the bones they have to break. Every one of these circumstances will have its effect on the development of all the parts which assist in moving the jaw. That the claws may be able to seize the prey, there must be a certain amount of flexibility in the toes and of strength in the nails, and this requires a peculiar form of the bones and a corresponding distribution of the muscles and tendons. The forearm must possess a certain facility in turning, whence also result certain forms of the bones of which it is made up, and these bones of the forearm, articulating to the humerus, cannot undergo change without corresponding changes taking place in this latter bone. The bones of the shoulder also require to have a certain degree of strength when the anterior extremities are to be used in seizing prey. In this way, again, other special forms become involved. The proper and free play of all these parts requires certain proportions in all the muscles concerned in the motions of the foreleg, and the impression of the muscles so proportioned will determine still more definitely the structure of the bones. It is easy to perceive that similar conclusions might be drawn as to the structure of the posterior extremities which contribute to the rapidity of the general movement of the body, or of the vertebrae which influence the facility of those movements, and also as to the structure of the bones of the face, in their relation to the degree of development of the external senses. In a word, the structure of a tooth involves that of the socket in the shoulder bone and of the nails, just as, to use a mathematical but very apt illustration, the equation to a curve involves all the properties of the curve. And as the curve may be drawn when we know the root of the equation, so in comparative anatomy, by making each property separately the base of investigations, one may deduce all the other properties. Thus the shoulder bone, the articulation of the jaw, the thigh bone, or any other bone taken separately, gives the structure of the tooth, or conversely, from the tooth, a knowledge of all these peculiarities may be derived, so that, taking any one bone, he who is familiar with the laws of the animal economy may reproduce the whole animal. Ansted. End quote. Relative ages of the principal catastrophes of the globe. From observations, it would seem that the dry land must have appeared in successive portions, to cause on the surface all the variations of nature, form, humidity, and dryness, the combination of which should procure for man all the happiness designed for him by the Creator. The study of the successive appearances of land is now one of the most beautiful points of view in which geology can be presented. We are indebted to M. Elie de Beaumont for pointing out the course to follow to establish the chronological order of the principal catastrophes which happened in Europe, and around which all facts of the same nature may be grouped. As soon as we perceive some part of inclined sedimentary beds, we may decide that they have been displaced from their ordinary position by upheaval. The period of this accident remains at first undetermined. But if, at the base of more or less elevated projections which these beds produce, we find other sediments deposited in horizontal strata, resting against the preceding, it becomes evident that the upheaval of the first took place after the formation of the second, which are still found as they were when they were deposited from water. We now have a term of comparison, and, if we succeed in recognizing the relative age of the horizontal deposit, we also have an epoch of the catastrophe, relatively determined, which produced the uptilting of the other. These differences of stratification are everywhere seen on the sides of mountains, and we then see that the several sedimentary deposits, A, B, C, are not all in the same position. In certain places the stratum A, for example, is uptilted, and the stratum B is horizontal. In another, A and B are both uptilted, and C is horizontal. In a third, A and B and C are uptilted together, and another stratum, D, rests upon them. We must infer from these observations that a first upheaval took place after the formation of A, and before that of B. A second took place between the strata B and C, a third between C and D, etc., and so on, chronologically as far as they have been observed. Systems of upheaval. If the inclined position of sedimentary strata reveals to us the existence of upheavals, the strike or direction of these beds, which is nothing but the line produced by their swelling upwards, or the crest or ridge resulting from their rupture, shows us the course followed by the phenomenon. Hence it follows we may take one fact for the other as the basis of observation, and that the different directions, strikes, of mountain chains are also indications of the different kinds of upheaval. In fact, it has been long and perfectly established, on one hand, that the inclination of strata is intimately connected with the direction of chains, excepting the perturbations which result from crossings. On the other hand, we now know that the phenomenon of uptilting of a determinate number of beds extends as far as the chain itself. It has also been ascertained, at least for Europe, that parallel chains correspond, in general, in the epoch of upheaval. That is, in these chains, strata of the same age are found everywhere uptilted, and that the succeeding ones are horizontal. It follows from this circumstance that an upheaval does not take place purely on a mathematical line, but on a band of formations more or less wide, on which it is manifested by several parallel ridges. The same line does not continue always from one end to the other, but we find here and there high and low parts, and those which are concealed by the subsequent deposits. Therefore, it is the common line of all the elevated ridges which must be taken for the general direction or strike. The word strike is formed from the German streichen, to stretch, to extend. The assemblage of directions on the same line, and parallel directions, form what is called a system of upheaval, which is synonymous with the expressions system of fractures, system of uptilted beds, and even system of mountains, although in a more restricted sense than in geography. To designate the different systems, the names of places in which each system is particularly developed have been borrowed. We say system of the Pyrenees, system of the Western Alps, etc. The great catastrophes which have successively occurred on the surface of the globe appear to have always taken place suddenly. At greater or less distances from places where the stratification is unconformable, we often find the same deposits in conformable stratification, and even joined to each other by a gradual passage. Hence it follows that deposition has not been suspended, but the movement of the soil has been local over a more or less considerable space of the terrestrial surface, and the interval during which it took place must have been extremely short. This is clearly seen, for example, at the period of the system of the Rhine, in which the Vosgian sandstone is found upheaved, without the Bunter sandstein having participated in the action. And nevertheless, at a short distance, the two arenaceous deposits, where their stratification is conformable, are so joined to each other that it cannot be determined where one begins or the other ends. The same is the case with the Cretaceous formations. If their different deposits are dislocated in a certain direction, they are conformable for great extents, and they then pass from one to the other in such a manner that they were for a long time confounded as a single formation. Submerged and uncovered formations. Sedimentary beds found resting horizontally on the sides of mountains show that the sea beat against escarpments by deposits upheaved in an anterior epoch. Hence the expression of the sea of this or that formation as the Cretaceous Sea, the Jurassic Sea, etc., which indicate the waters beneath which each of these sedimentary deposits was formed. When a deposit is wanting in a certain extent of formation, we should infer the formation was then above the sea of the epoch, and formed there a more or less elevated island or continent. Thus, at the time when the Parisian limestone was formed, a great part of France, and indeed of Europe, must have been dry, as we scarcely see traces of these deposits anywhere except in the neighbourhood of Paris or Bordeaux. But it also happens that the deposits which we must regard as having been dry at a certain time were afterwards covered by marine sediment, more modern than the preceding, and hence we must conclude that, although uncovered prior to the anterior formation, they must have afterwards sunk to receive new deposits. Such sinkings make certain catastrophes particularly remarkable. The several systems of upheaval have been classed according to their direction, and the epochs in which they occurred. The following table exhibits the supposed epochs of the European upheavals. First, upheaval or system of Hunsrück, between the Cambrian and Silurian formations. Second, upheaval or system of Ballons, between the Silurian and the Coal formations. Third, upheaval or system of the north of England, between the Coal and Pennine formations. Fourth, upheaval or system of Hainaut, between the Pennine and Vosgian formations. Fifth, upheaval or system of the Rhine, between the Vosgian and Trias formations. Sixth, upheaval or system of the Thuringerwald, between the Trias and Jurassic formations. Seventh, upheaval or system of Côte d'Or, between the Jurassic and Greensand formations. Eighth, upheaval or system of Mont Viso, between the two Cretaceous formations. Ninth, upheaval or system of Corsica, between the Parisian limestone and the Molasse formations. 11th, upheaval or system of the Western Alps, between the Molasse and Subapennine formations. 12th, upheaval or system of the Principal Alps, between the Subapennine and Diluvium. 13th, upheaval or system of Tenaire, between the Diluvium and perhaps some modern alluvions. Since in Europe the different great chains of the same direction, which are found on the same line or on parallel lines, belong to the same epoch of upheaval, there is room to suppose, as nothing indicates limits to the phenomena which gave rise to them, that the same effects were continued far beyond the countries whose geological structure is known. Hence it follows that wherever we find parallelism in the chains, we should be led to believe also that the formations were contemporaneous. It is at least interesting to examine, under this point of view, the principal chains we are acquainted with. The direction of the Pyrenees extends from the Alleghanies in North America to the peninsula of India, through the Carpathian Mountains, a part of the Caucasus, the mountains of Persia, from Erivan to the Persian Gulf, and through the Ghats, which determine the position of the coast of Malabar. To the south of this line or direction, several parallel ridges are also represented. Those which go from Cape Ortegal in Asturias to Cape Crow in Catalonia, the small chain of Granada which ends in Cape de Gat, the mountains which bound the desert of Sahara on the north, cutting the direction of Atlas, finally the Apennines, the Julian Alps, the mountains of Croatia, of Romelia, and those of Moria. The system of Ballons, so near to that of the Pyrenees, appears to be represented also in the Alleghanies. It is to be observed on the coast of Brittany, and will no doubt be found in several of the groups just mentioned when careful study enables us to distinguish it from the neighboring system. The direction of the Western Alps is remarked from the Empire of Morocco to Nova Zembla, passing through the eastern coast of Spain, the south of France, and a great part of the peninsula of Scandinavia. It is recognized in the Cordillera of Brazil, from Cape St. Roque to Montevideo. Parallel to the direction, the same system is seen in the Kingdom of Tunis, in Sicily, the point of Italy, and in Asia Minor. All the shore of the ancient continent, from North Cape and Lapland to Cape Blanco in Africa, is parallel to the direction of the system. The principal Alps form part of a system of direction of great extent. From the chains of Spain and those of Atlas, in the northern part of Africa, we find parallel chains which extend to the China Sea. On this line of direction we find, starting from Sicily and Italy, the chains of Olympus in Greece, the Balkan, Taurus, the central chain of Caucasus, crowned by Elbrus, between the Black and Caspian Seas, the long series of mountains which extend through Persia and Kabul, comprehending Paropamisus, Hindukush, etc. Finally, Himalaya, the highest mountain in the world. State of Europe at different epochs of formation. From what has been stated, we are led to infer that the surface of the globe, so often disturbed, must have presented great variations in the relative extent of land and sea, and successively passed through many different shapes to reach its present state. But even in Europe, the only part of the world in relation to which positive information has been obtained, it is very difficult to say what may have been its condition in the most ancient epochs. The reason of this is, that having for a long time confounded, under the name of transition formation, deposits of very different epochs, we are not now able to distinguish with sufficient clearness throughout the limits of different formations comprised in it. Nor do we know, and this is a great obstacle to tracing the continents of the ancient world, what parts were successively sunk at each catastrophe, and the extent of which we can only know from induction. It was not until after the appearance of the Jurassic formation, the limits of which are clearly marked, that we are able to distinguish, with precision, the shape and extent of lands in the midst of the seas in which these deposits were formed. By the term epoch of this or that formation, we understand the period of time during which the formation was produced beneath the sea, around the upheaved deposits of the preceding epoch. For example, the Jurassic epoch indicates the time during which the deposits of the Jura were formed in the seas, where the upheaved deposits of the Trias and all that preceded were traced. The term sea of such an epoch, as Jurassic Sea, Cretaceous Sea, etc., is often used in the same sense. Silurian and Devonian epoch. At the time when the Silurian and Devonian systems were formed in the midst of seas, it is evident there were different portions of land in Europe uncovered, which resulted as much from the upheaval of the Hunsrück as from previous catastrophes. We have seen those of considerable extent which entirely escaped these deposits, and which, in consequence, must have been raised above the waters in which they were formed. In France there was at least one island, of the Cambrian formation, near the Gulf of St. Malo, on a part of Brittany and of Normandy. The great granitic plateau, which comprises Limousin, Auvergne, etc., where the upheaval of the Hunsrück was manifest by the direction of certain uptilted beds of gneiss, and by the anfractuosities in which the coal formation was subsequently deposited, must have been at that time above water, and perhaps adjoined at the south to the ancient group which preceded the Pyrenees. The mountains of Moraz also existed, and perhaps a part of the formations comprised between Toulon and Innsbruck, in a southwest and northeast direction. Some parts of the centre of Vosges and of the Black Forest, Eifel, the Hunsrück, where the first upheaval is clearly indicated, and Ardennes were necessarily above water, as well as the county of Nassau, the Harz, all the centre of Germany, including Saxony, Bohemia, and Moravia. The same is true of Scandinavia, and a part of the British Islands. From this moment lands were covered with vegetation, in arborescent ferns, Equisetaceae, etc., sufficiently abundant to form the masses of anthracite formed in the Devonian formation. The seas were then inhabited by trilobites, orthoceratites, orthis, productus, different kinds of terebratula, and several species of polyparia, of the same genus as those found in madreporic reefs, which, as well as the tree forms, indicate a climate analogous to that of present tropics. All these circumstances show that heat was not in that epoch distributed over the surface of the globe as it now is. Without doubt, the increase of temperature from the surface to the interior was more rapid. All springs were warm, and according to M. Elie de Beaumont, the fogs, which were the result, hindering radiation, in the absence of the sun, everywhere tempered the rigor of winter, and thereby augmented the mean temperature of the seasons. Coal epoch. The upheaval of the Ballons, in bringing today the Silurian and Devonian deposits, no doubt, increased the extent of lands, and more or less changed their configuration. Vegetation must have been prodigiously developed at that time, and over vast surfaces, which is proved by the enormous mass of coal formed, and the manner in which the deposits are piled up. On one hand, the carboniferous limestone and the different marine beds found in the midst of the sandstone of the coal formation itself seem to indicate at first a deep sea, and perhaps afterwards an immense maritime marsh, which extended from Ardennes and the Harz to the ancient mountains of the British Islands. On the other hand, the numerous coal basins known to exist in the surface of France and central Germany clearly show there were extensive lands on which marshes were found, here and there, in which were formed, just as peat bogs are in our times, all the coal deposits we have discovered. The ancient and uncovered formations which constitute Brittany and the central plateau of France clearly indicate high land on which are found the lakes of Bayeux, Quimper, Laval, and Vouvant, placed between in the infractuosities caused by upheaval of the ballons. Then those of Burgundy, Limousin, Auvergne, Forez, etc., situated on a direction parallel to the elevation of the Hunsrück. This land, the limits of which cannot be fixed, extended at least to a peninsula towards Strasbourg. To the east of this land, and perhaps united to it, there is another, which was evidently uncovered because there is nothing of the Pennine formation deposited on it. The latter probably extended over the space now occupied by Innsbruck, Milan, Briançon, Genes, Nice, Toulon, and to the islands of Corsica. Towards Toulon are the marshes in which was formed the coal now found in that part of France. Lands also evidently existed over the space occupied by Bohemia and Saxony, with several coal lakes on their surface. The coal deposits of Moravia and Galicia seem to show their extension towards these countries. There was one island at least between Cologne and Frankfort, presenting in its southern part the great coal basin of the country of Treves, and uniting at the north with the ancient formation of the Harz. Dry land also existed in the peninsula of Scandinavia, where nothing has been deposited since the Silurian formations, but it seems to have been sterile and without swamps, for it affords no trace of coal. We are entirely ignorant of what existed where the great cities now stand, but the absence of carboniferous limestone out of Belgium and England may lead us to think that a great portion of Western Europe was then uncovered, and perhaps presented coal lakes, which subsequent catastrophes have sunk beneath the seas. A part of the land just mentioned has always remained uncovered to the present time, or has been even upheaved more and more by various subsequent catastrophes, as Brittany and the central plateau of France. At certain points, in fact, coal deposits have been pushed upward to a great height, as the plateau of Santa Fe de Bogota, and in the Cordillera of Huarochirí, where some are found from 2,700 to 4,600 yards above the sea. In other places, on the contrary, it is evident the formations have sunk, to be covered by more modern deposits, through which the coal is sought in the depth, as at Anzin under the chalk, and Vosges under the red sandstone, and Cevennes under the Jurassic limestone, etc., and in general on the borders of new formations exposed by subsequent catastrophes. Without doubt there is some deeply buried and forever lost to us, either under different sediments or under water, as at Whitehaven in England, where the mine extends more than 1/4 of a league from the shore, and 100 yards beneath the bottom of the sea. The vegetation of this epoch, favoured no doubt by the insular form of the land, as now is in all islands, consisted of Lycopodiaceae, Equisetaceae, ferns, etc., of arborescent species, the analogous of which are no longer found except within the tropics, with conifers resembling the Araucaria. The mass of coal was formed of their debris, with cellular cryptogamia, which then grew under water, as now in peat marshes, and under a still more favourable temperature for their development. The seas of this epoch had lost their trilobites, but contained in great abundance spirifers, productus, orthoceras of particular species, different cephalopods analogous to the nautilus and argonaut, and various other shells. The encrinites were so extensively multiplied that their debris constitute, almost of themselves, certain varieties of Flemish and Belgian marble. Sauroid fishes of great size and especially vigorous organization then existed, and the family of sharks, still feeble, presented cestracions and hybodons. The fresh waters which fed the coal marshes contained, as it appears, few conchiferous mollusks. The debris which are rarely found resemble anodonta and unio. Fishes were numerous in some localities. They belonged in the genera Paleonyiscus and Amblypterus, living, without doubt, in the rivulets which meandered at the bottom of abrupt fractures of the ancient formation. Pennine epoch. The disturbance caused by the upheaval of the north of England appears to have exerted more influence on the surface of the then uncovered lands than on their extent and form. Only the bottom of the sea, where the coal beds of England and Belgium were formed, was elevated in part to escape, like all France, to the Pennine Formation. On the other hand, a small corner of the southwest of Vosges must have sunk under water to receive the red sandstones which there cover the coal formation. Further in Mansfield, the presence of the Pennine Formation, which is there developed on a great scale with its shell limestones, demonstrate the submersion of the country beneath sea water. It was also beneath the sea, in the country of York, that Magnesian limestone was deposited, which there represents the whole formation of this epoch. Very little is known of the terrestrial flora of that time, for we find little, save the algae in the bituminous schists of Mansfield, and some silicified trunks of conifers in the sandstone. Deposits of coal suddenly ceased to form, and it seems from that time there were neither ponds nor rivulets on the lands. Nevertheless, there were still divers fishes of the genus Palaeonychus, which lived perhaps as well in salt as in fresh water. The land was for the first time inhabited by saurian reptiles, resembling the iguana and monitor, the remains of which are found in cuprous schists. The seas beneath which all these deposits were formed contain the same genera, often the same species of mollusks and radiata as those in which the carboniferous deposits were formed. Vosgian epoch. The system of Hainault, in dislocating the coal formation and ridging the surface of the land, had little influence on its form. In the Vosges, some of the points where the red sandstone were deposited were elevated, around Saint Dia, Schelestad, Mont Bellard, and escaped the succeeding formations, while all the rest of the chain, which had escaped the deposits of the red sandstone and consequently found elevated at this epoch, must have been sunk now to receive the Vosgian sandstone. The same has taken place in the Black Forest. Such was the state of things in this modification, that animals could not have lived on this part of the earth, and that plants, if any then existed on the surrounding soil, could not have been carried under the waters except in very small numbers. The Trias epoch. After the system of the Rhine, subsequent to which the Vosgian sandstone was upheaved, Vosges and the Black Forest underwent a little change in shape, but other lands in Europe have undergone scarcely any modification. We observe only a secondary elevation of the central plateau of France, by the peripheroid granites of Lozère, by the hills which edge the coal formation from Fins to Mauriac. Subsidences occurred, on the other hand, in Bourbonnais, in Rouergue, as well as in lands between Toulon and Nice. Vegetation then underwent great modifications. The ferns and Equisetaceae of great height had considerably diminished, and conifers, on the contrary, became more numerous. Plants analogous to Zamia and perhaps to Cycas then formed an important part of the flora of Europe, beginning a prelude to the immense development they took in the succeeding epoch. In this epoch new saurians appeared, and traces of birds, which had not appeared in preceding epochs, are recognized. It was at this period also that those creatures existed, whatever they were, whose tracks are found imprinted on Bunter sandstein freshly lifted above water. Mr. Owen, who considers them enormous batrachians, supposes them to have been of the form represented. The Jurassic epoch, at the same time of the elevation of Thuringewald, the Triassic formation, which had just been deposited beneath the sea, was upheaved at different points. Some patches of Bunter sandstein were added around the central plateau of France, between Moulins and La Châtre, between Brives and Tulle, in the environs of Rodez, of Saint Afrique, and of Lodive. The island of Var was increased from these sandstones and Conchylian limestone. The Vosges and Black Forest were also considerably augmented, the one to the west in Lorraine, the other to the east, extending into Germany, and uniting various islands which had been separate till then. The same was the case with different islets, which already marked the place of the British Islands, and were then united to a continuous land by Triassic deposits upheaved between them and with them. But at the same time that the new lands were raised above water, there were great subsidences in those which previously existed. The land which extended from Cherbourg to Perpignan was then divided towards Poitiers, forming a strait now occupied by the Jurassic deposits. It was variously divided on its borders and almost cut again towards Rodez. That which extended from Nice towards Innsbruck was entirely sunk to receive the new deposit which covers it. If perchance there existed at the period of the coal some portions of land where Paris, London, etc. now are, everything leads to the belief that they then disappeared, for the Jurassic formation appears to be prolonged everywhere beneath the soil which serves them as a base. All the data on the state of Western Europe at the period of which we speak are furnished by the presence and disposition of the Jurassic deposits. Developed on a vast scale and upheaved later from the bosom of the waters, they clearly show what was then the configuration of the lands around which they were formed under the sea. The ocean of the Jurassic epoch also had its peculiar characteristics. It was inhabited by saurians, eminently swimmers, the Ichthyosaurus and Plesiosaurus, whose paws, in form of paddles, remind us of those of the chelonians of the present day. These voracious animals, all aquatic, took the place of the sauroid fishes of the Carboniferous group, which had now disappeared. At the same period lived those flying saurians, called pterodactyls, which peopled the air and completed the series of singular creatures of an ancient creation, now entirely annihilated, the exterior forms of which Dr. Buckland has attempted to paint from the skeleton. Those seas had lost the Productus, and spirifers had almost disappeared. The numerous terebraculi which lived in this epoch belonged to species entirely different from those seen in the preceding seas, but there were found a great number of mollusks with chambered shells, and generally called ammonites, the race of which, as yet little developed, had begun to appear in the seas of the Trias. There existed belemnites, the remains of which, until then unknown, are numerous from the lias to the chalk. In the Gryphea, arcuata multiplied there for a moment to disappear afterwards, when the lias was formed, and to give place to other species of the same genus. As at present coral reefs were formed in those seas, remains of which are found, showing a mean temperature analogous to that of our intertropic seas. On the land, freshwater lakes, without doubt, supported paludini, and the freshwater streams carried helices, remains of which are now found in the Portland group. There must have existed also on land several species of insects, which served to feed the pterodactyls, the remains of which seem to show they were Coleoptera and Neuroptera, resembling the Bubrestes and the Liblui. Small marsupial mammals, analogous to possums, were met there, a skeleton of which was found in the beds of Stonesfield, but these creatures seem to have been in small numbers, if we judge from the remains that have been as yet found, and no one of the great animals which characterize the Parisian epoch has been found with them. The flora was not the same as that which furnished so many remains to the coal formation. The Lycopodiaceae and the gigantic ferns had disappeared, and it seems that many new species had been created after the Pennine and Triassic epochs. Then the Cycadiae and conifers considerably exceeded all other families, and probably some palms were already in existence, the fruits of which are found in the lias. Also, the carbonaceous combustible formed in this epoch is very different from that of the great coal formation. They were at the same time much less abundant, which indicates a great difference in the extent of lands. End of Lesson 10, Part 2. Lesson 10, Part 3 of Elements of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Amy Gramour. Elements of Geology by William Ruschenberger. Lesson 10, Part 3. Cretaceous Epoch. After the system of upheaval of Côte d'Or, which elevated a part of the Jurassic deposits above the sea, the form and disposition of continents were considerably changed. The inferior limits of the chalk mark the shape of lands which then existed, and determine the extent of the seas of the epoch. The three islands of the preceding epoch were now united, but without any change of shape. Brussels, which was inland, was now found on the coast. Aarhus, Dunkirk, Maastricht, Wesel, Breslau, and Vienna were sunk under water. A lake was formed between Dresden, Brunn, and Prague. A strait was found in the place of Perpignan and Carcassonne, and what existed previously to the Pyrenees was in part submerged. By compensation, the Vosges, washed by the sea in preceding ages, was then found in the middle of the continent which joined the central island of France. The space of sea which separated them was filled up. Langres, Nevers, Lyons, Toulouse, and Oxford were on terra firma, and an isthmus was formed about Poictiers to join the great island that existed to the west. A shore extended from the environs of Cracovia to about Perpignan by Ratisbon, the position of which was not changed, and to Zurich and Lyons. An immense gulf was formed between Brussels and Oxford, extending to Poictiers. Between Salzburg and Avignon, a new island was formed, which marked the future site of the Alps. Briançon, Turin, Trent, and Innsbruck might have been already placed there, but Switzerland was then a channel which separated this island from terra firma. The island of Toulon was at the time limited, and some small islands marked the environs of Marseille. Little change, however, had taken place in living creatures. At the same time, diverse species of ferns and Cicadae vegetated on the soil. Conifers, especially, became more and more abundant, and gave origin to masses of lignite found at the base of the chalky formations. But there were few terrestrial mammals, for no remains of them are found in the chalk, although they were met with in Jurassic deposits. There existed, however, diverse Cetaceae, such as lamantins and dolphins, some of which had already appeared in the Jurassic seas. Reptiles were among the animals capable of living on the earth, still the most elevated creatures of the creation. Aquatic and terrestrial species were very numerous. Among them were the iguanodon, the megalosaurus, and diverse crocodiles. Fluviatile tortoises, fishes, and mollusks of fresh water lived on the borders of lakes or in their waters. The seas fed baculites and turrilites, of whose interior existence there is no trace, and which, towards the end of the epoch, disappeared at the same time with all mollusks having peculiar chambered shells. Here and there true sharks existed, and have been continued to the present time, although their dimensions are considerably diminished. Parisian epoch. The upheaval of Mount Viso, and later that which gave birth to the Pyrenees, to the Apennines, and all the parallel chains we have cited, prodigiously changed the geographical constitution previously established. The last especially produced one of the greatest convulsions Europe has experienced. Everything was shaken by it, and the greatest part of what was then under water was elevated above it, to form an immense continent. This proves the little extension of the Parisian sediments then formed, and which are found concentrated, one part in Belgium, Artois, Picardy, Isle of France, Normandy, and the opposite coasts of England, and the other in the environs of Bordeaux. Very few traces are found elsewhere. Hence it follows that the seas of this formation did not penetrate far into this continent, although they covered the two capitals of the world. Of the vast ocean of preceding ages, there only remained a part of the gulf already limited, about Cambridge, Oxford, Exeter, Cherbourg, Angers, and Poictiers, which was then narrowed in many places, and widened elsewhere at the expense of the ancient peninsula of Brussels. It probably communicated with some remains of the North Sea. In the middle were two islands of chalk, the Wealds of England, and the country of Bray in France. Another portion of the gulf also remained between Bordeaux and Dax. The fauna of the land, at the Parisian epoch, was very different from what it had been in preceding epochs. The gigantic saurians had disappeared, but there remained great freshwater crocodiles, marine and lacustrine chelonians, and the earth was inhabited by mammals. The last were then pachyderms, analogous to tapirs, as the Anoplotherium and Paleotherium, which must have been nearly of the form represented. They lived at the same time with some carnivora of the genus dog, etc. belemnites, and all similarly chambered shells had disappeared from the seas. The nautilus only remained, and it lived with the Cerathium giganticum, and a multitude of species of mollusk, more or less resembling those of existing seas. At this age of our planet, the flora of Europe was still modified. The Cycadiae had disappeared, and the conifers, presenting still new species, to which were joined the dicotyledons, were found with palms to the centre of Europe. The last, which are not now found closer than Africa, at the nearest point, evidently indicates a mean temperature higher than what we enjoy now, which must have been about 72°, the present mean temperature of Lower Egypt. This circumstance may be attributed to the fact that the increase of internal heat was greater than at present, and that the fogs, by diminishing radiation, rendered the winters less rigorous. Watercourses necessarily must have existed on the continent, and may account for deposits of lignite and the remains of freshwater mollusks being found in place in the midst of marine deposits. We are especially led to suppose that one of these watercourses, emptying about Laon and carrying lacustrine deposits from Soissonnais, and another, somewhere between Exeter and Oxford, formed the deposits of the Isle of Wight, at the southwest of the Wealds. Around Paris, some parts of the sea must have been separated from the rest, at a certain time, and converted into a freshwater lake, in which the gypsum was formed. Epoch of the Molasse. It was after the system of Corsica that the molasse was formed, and in such a manner that it is generally deposited where the Parisian limestone is entirely wanting. It follows that lands which were then elevated above the waters must have necessarily sunk, often to great depths, to receive this new formation, which is sometimes extremely thick. Consequently, great modifications of the continent of the preceding epoch again took place. Partial subsidences must have occurred in many parts of Touraine, of Guyenne, of Gascony, Languedoc, Provence, Dauphiny, and also in all Switzerland, etc. Lakes were formed, often extensive, sometimes isolated, and sometimes communicating with the sea, and it is this which indicates the contemporaneous deposits, some of which are fluviatile and others marine. In opposition, more or less considerable upheavals took place at the same time in many parts of the northern Gulf, in Belgium, in Picardy, in the Isle of France, and all the coast of England. The marine limestone, laid bare, escaped in all this extent. The succeeding deposits in the sites of London and Paris were brought to light, although surrounded by water in which the molasse was deposited. It was the same in the Gulf of Bordeaux, where all the northern part of the Parisian formation was upheaved, and escaped the deposit of the molasse, which is found in all the rest of the present basin, which was from that time submerged. This epoch was accompanied by a new change in the creatures which lived on the surface of the soil, and from that moment, besides some new species of Palotherium, mastodons and the Dinotherium giganticum appeared in Europe, the last nearly of the form represented, as well as the rhinoceros, hippopotamus, monkeys, and many rodents, as castors, squirrels, etc. The flora was principally composed of conifers, with dicotyledons, which, however, had not attained, in all probability, the development they acquired in the succeeding epoch. There still existed palms, the remains of which are found in deposits of lignite, and particularly in those of Liblar, near Cologne, as well as in the plaster works of Aix. Sub-Apennine epoch. The upheaval of the Western Alps caused a new disturbance. Not only the soil comprised between Constance and Marseilles, rendered mountainous by preceding events, suddenly assumed a considerable height, and a great part of the relief it now presents, but still the movement extended over all Europe. The greatest part of the Anglo-French Gulf was filled by an elevation which brought to day all that is referred to the molasse. It was the same in Guyenne, in Languedoc, in Provence, in Piedmont and Switzerland, and the form of the seas was once again changed. But in time great lakes were formed in the interior of the lands, one from Dijon to near the Isère, another in the southern part of Alsace, and a third in Provence from Sisteron to the borders of the Durance. At the same time, all the carnivora appeared of the genera Ursus, Hyena, Felis, Canis, etc., which inhabited caverns. Their remains are not found in the Parisian formation. Their species disappeared not only from the European continent, but from the face of the globe in the next epoch. There also appeared several new rodents, horses, ruminants, and probably the gigantic edontate animal with slow and heavy gait, the Megatherium, whose head and whole aspect were similar to the sloth's, although its size was that of the largest rhinoceros, and its body must have been covered by a bony cuirass like the armadillo. Epoch of Diluvium. At this time Europe took its present form, and its relief was definitely fixed. The upheaval of the principal Alps, in forming all the chains which extend to Austria, in elevating likewise some portions of the Western Alps, also raised up the soil in a great part of Europe, and especially caused the division of the waters between the ocean and the Mediterranean. The effects produced show that enormous currents of water were established in all directions, which furrowed all the deposits then uncovered, but the volume of waters furnished by lakes, previously formed in the interior of lands, whose barriers were no doubt broken in the new catastrophe of upheaval, was in relation to the vastness of the result produced. It must have been prodigiously increased by some circumstances, attributable, perhaps, to the sudden melting of the snows and glaciers then accumulated on the Western Alps. The currents which were formed, in furrowing the surface of lands, carried their debris in all directions. Hence the alluvions of the valley of the Rhone, of Crau, of the plains of Lombardy, those of Bavaria, the valley of the Rhine, etc. Hence the last configuration of the valleys, the denudations, and the dislocations seen in so many different places. It is from the upheaval of this part of the Alps that the separation of France and England appears to date, as well as that of Ireland, by ruptures effected between Brest and Cape Lazard, between Carnarvon and Dublin. It was then that the Mediterranean took its present limits, in consequence of the subsidence of formations which extended to the south of Marseilles, at the epoch of the Parisian Sea. The Gulf of Bothnia was perhaps produced in this epoch, since the shell deposits found on some points of the coast are all referred to the subapennine formations. But change of configuration in the soil was not the only consequence of the appearance of the principal Alps. This catastrophe, extending over a great part of the world, from the height of Spain to the centre of Asia, was marked by the sudden cooling of European countries to their present temperature. From that time palms ceased to grow in Europe, and dicotyledonous plants were prodigiously increased. The rhinoceros, elephants, and panthers, which had just appeared in that part of the world, became entirely extinct there. And if the cavern bear is represented in our present bear, its size is considerably diminished. The fauna of that part of the world was again completely changed, and replaced by that we now see. Besides, it was at this moment, probably, that man appeared on the earth. In fact, on one hand, there are no human remains in what has been too lightly named diluvium, for the skeletons of Guadeloupe are of the modern epoch, and cannot be reckoned, and on the other, the animals which then began are precisely those with which man has always lived, since historic time. Modern epoch. From the epoch of the principal Alps, no general geological disturbance has taken place in Europe, and some volcanic eruptions and upheavals, produced by earthquakes, are the only effects that have been manifest. Such also appears to have been the action of the 13th upheaval, which was revealed in the Morea, in Naples, Sicily, and in some parts of Provence, and which, perhaps, also determined the eruption of the modern volcanoes of Auvergne and Vivarais. Though ancient fissures, the beautiful preservation of which attests their posterity to the great denudations which followed the events of the principal Alps. But if scarcely anything occurred in Europe after this great event, perhaps it was not the same in other parts of the world. We may suspect that a great part of the immense mountain range which extends through America, and traverses Asia from Kamchatka to the Burman Empire, is the result of a more recent catastrophe. This direction, at least, offers the most extended, the most decided, and, so to speak, the least effaced feature of the exterior configuration of the earth. It is there we see the greatest number of active volcanoes, and consequently the most extensive and best preserved communication between the interior and exterior of the globe, and perhaps also the greatest mass of volcanic products known. Deluge. The successive appearance of the great mountain chains has produced great disturbances in different parts of the globe. But it is evident that these catastrophes, at least those of great energy, and those which extended over large spaces, as the upheavals of the Alps, Pyrenees, etc., must have manifested their action over all the rest of the earth in secondary phenomena of more or less importance. If a simple earthquake is enough to produce a violent agitation of the sea, a sudden eruption of waters on continents, these terrible revolutions could not have failed to cause more or less impetuous movements in the ocean, and temporary derangement of level of more or less extent. Hence, without doubt, the extraordinary inundations which, at each catastrophe, have ravaged the surface of existing lands, and produced, as in our day, various denudations, or superficial alluvions, of more or less extent. Now, since, without counting all that escaped the investigations of science, we clearly see, in Europe, a series of successive movements of the soil, which have modified the whole continent, and many even a whole hemisphere, there is nothing absurd in admitting that what took place at so many different times, from the most ancient to the most modern epochs of formation, may have happened once, somewhere after the appearance of man on the earth. Consequently, there is nothing contrary to reason in the belief of a great eruption of water over the lands, a general inundation, a deluge, in fact, which we find described not only in the Bible, but deeply impressed in the traditions of all people, and at an almost uniform date. Thus, in recognizing in the recital of Moses the extraordinary circumstances which bear witness to the supernatural intervention of the divine will, we see on one hand the material possibility of the fact transmitted to us, and on the other hand we find even the secret of the means brought into play, that is, the upheavals, the subsidences, the consequent oscillations of the water, which from that time became efficient causes of the great chastisement then inflicted on the human race. If, because the known results it had produced are feeble, we cannot too carefully seek the cause of this great phenomenon in the last of the upheavals to this time classed, which dislocated the deposits in which traces of human industry have already been found, perhaps it may be discovered in that which caused the rise of the Andes in America, and the volcanic chain of Central Asia, which, with a colossal development, also present striking characters of relative novelty. As to the future of our planet, everything leads to a belief that the state of tranquillity we now enjoy is but temporary, like all the intervals of crises during which the different sedimentary deposits were formed. In fact, in the series of perturbations which, through all time, have formed part of the mechanism of nature, we perceive no law authorizing us to conceive a termination to the succession of these phenomena. To accidents of little importance succeed indistinctly, either crises of the same order or frightful catastrophes. Long periods of tranquillity suddenly succeed terrible convulsions. To the small upheaval of Mount Viso, for example, succeeded the great catastrophe of the Pyrenees. To this the small accidents of the system of Corsica, which were followed by the great event of the Alps. The long period of the Jurassic formation was disturbed by the upheaval of Côte d'Or, as the deposit of the Vosgian sandstone was almost immediately arrested by the system of the Rhine. All was irregular in those revolutions of which we have acquired a knowledge. No fact presents itself suggesting the idea of a gradual diminution in the intensity of subterranean actions, and leading us to think the earth has lost the property of being successively broken and ridged in all directions. Nothing, therefore, can assure us that the period of calm in which we have lived for upwards of 5,000 years, the period of the deluge, will not be disturbed in its turn unexpectedly by the appearance of some new system of mountains, the effect of a new dislocation of the soil, the foundations of which earthquakes show not to be unshakable. Hence it follows that the idea of an end, or a renewal of things here below, as widely spread as the great inundation which has passed, is also in the order of the laws which govern the universe. Geogeny. The history of the various systems which have been imagined to explain the origin of the universe, and of the earth in particular, might perhaps afford some attraction to the curious. But besides occupying a great deal of time in pure romance, it is, perhaps, better to forget the many mental vagaries we should be forced to expose. A single geogeny is worthy of our attention. It is that which is related in the Book of Moses, and which, after a lapse of more than 3,000 years, still presents, on one hand, the clearest application to the best established theories, and on the other, the most succinct account of the great geological facts. What is more rational, in fact, and more in conformity with even our most precise knowledge, when we think of bringing order into the general confusion of things, than to create the vehicle by means of which the phenomena of light, of heat, etc., may be manifest, and infuse life everywhere, than to collect the scattered elements into groups separate from each other, than to establish here and there centres of attraction around which all may gravitate according to an immutable law. Nevertheless, this is what we find, with fewer details, no doubt, than we could give by means of our acquired knowledge, in brief and common language intelligible to all, in the first verses of Genesis, which thus state 3 successive and distinct facts. We there find indeed an outline, deus fecit, lucum, the fluid of light, of heat, etc., firmamentum, space and all the masses scattered through it, solum et stellas, the centres of attraction, etc. As to the organic creation, it is divided into 4 successive and also rational epochs. The first established vegetative life, or life of nutrition, which is manifested not only in plants, but also in the inferior animals, in which we find scarcely any other phenomena than those of nutrition, growth, etc. Afterwards came the life of relation or sensibility, instinct, intelligence, and will, successively added, in different proportions, to the phenomena of simple existence. This new life first takes a certain development in fishes, including reptiles, no doubt, then birds, which together constitute the second epoch of creation. It acquired a new extension in mammals, which appeared at a third epoch, and finally reached its highest degree in man, with whom terminated the work of the Omnipotent, receiving a soul in the image of God, to distinguish him from all other creatures. This is, without doubt, a wonderful example of successive organic combinations, but it is also precisely the order in which all the remains buried in different ages successively present themselves. Those we meet in deposits we regard as the most ancient are the calcareous remains of certain polyparia, mussels, sometimes even the shell of some acephalous mollusks, the trilobite crustaceans, and the remains of plants, the accumulation of which formed the anthracite of the Devonian formations. The abundance, the extent, the thickness of these combustible beds announce the great luxuriance of vegetation, which leads us to believe that plants existed for a long time, and that perhaps their first debris have disappeared in the profound metamorphisms which modified the deposits in which they might have been. Fishes are not met with prior to the Devonian formations, and it is only in the coal deposits they present a strength of organization, which is lost in the succeeding deposits, and which is not known even now on the globe. Reptiles have left their remains in the new red sandstone, or penine formations which followed, and the birds, the creation of which Genesis also places in the same epoch, have left the imprints of their feet on the sandstones. Mammals did not appear until long afterwards. The traces of those found in the great oolite belong to the least perfect orders. It is only in the tertiary strata that their debris of every species are found in abundance. Human remains are not found in any of the beds which have been upheaved from the bosom of the waters, and now forming parts of our continents. It therefore follows that this privileged being of the general creation did not appear on the globe until after the animals whose fossil debris have been found. He dates from an epoch comparatively very recent, which is placed after the upheaval of the principal Alps. His formation would consequently go back about 6,800 years, according to admitted chronology. It is in the deposits formed under the waters since this catastrophe that the bones of man should be found, and they will not appear from that time in the series of geological beds until new revolutions shall have transformed the sediments still found under water into dry land. It is clear from this outline that the brief statement of sacred history is entirely in conformity with geological generalities. Observation alone enables us to add a great number of details, useless, no doubt, to most men, but interesting at least to the small number of those who dedicate themselves to study, if indeed they are not destined perhaps to enlighten their belief. The assemblage of data we now possess leads us to perceive that each of the particular creations briefly indicated in Genesis, with the exception of that of man, did not take place in a single moment; that, on the contrary, it was successively in a considerable space of time, and in proportion as the terrestrial globe itself was fashioned. Indeed, if the vascular cryptogamia appeared nearly from the commencement of things, the gymnospermous phanerogamia did not appear until about the epoch of the coal formation, and did not exist in abundance until long afterwards. It is the same with the monocotyledons, the remains of which are at first few and indistinct, and not clearly seen until after the chalk. The dicotyledons did not appear until still later, in the midst of the tertiary formations. In all this interval of time, the species successively changed, and those which were created have in turn also entirely disappeared, one after the other, to give place to the new. Fishes, reptiles, and mollusks respectively present us with the same phenomena, and still more clearly show the successive extinctions of the different races, and the appearance of many others. The sauroid fishes, which lived at the time that coal was formed in Belgium and England, disappeared for ever in the new order of things established in the Pennine formation. True sharks did not exist then, but appeared long after in the Cretaceous sea. Gigantic saurians, with paws in form of paddles, and flying saurians, existed in abundance in the Jurassic epoch, but disappeared in the following period, and were replaced in it by enormous terrestrial saurians, of which there are no previous traces, and, after long having inhabited the earth by themselves, the latter were also successively lost, leaving only crocodiles after them, still very different from those of the present day. The same is true of the trilobites, productus, and spirifers, which, after having multiplied for some time, disappeared one after the other. The ammonites and belemnites succeeded them, and are found in abundance in the Jurassic sea. Then they became completely extinct, after having successively changed species at the moment in which the chalk formation ceased to take place. All the mollusks that followed after more and more resemble those now existing, of which there was then no trace. Mammals present themselves under similar circumstances. The different orders and different species appeared only in succession. The first were only the feeble marsupials. Long afterwards came the pachyderms, analogous to the tapir, the first species of which were soon annihilated. Other species of the same genus succeeded them, and these were found associated with new animals, the mastodon and dinotherium, but they soon afterwards became extinct forever. Still later came the elephants. They only appeared with the carnivora, the rodentia, etc., the species of which were still only the prelude to those which appeared at the same time with man. All these successive changes in the series of creatures coincide with the great disturbances of the surface of the globe. It was at the instant of catastrophes produced by movements of the soil, that families, genera, species of organic bodies which had until then disappeared. In times of the succeeding calm, on the contrary, the new organization was developed in harmony with the new atmospheric circumstances and new dispositions of the isothermal lines, etc. These details, which observation enables us to add to the recital of Genesis, are in general harmony with the facts there found briefly enunciated, and of which they are but the development. The only difficulty presenting itself is that of the amplification of the word day, which happily, even in the eyes of legitimate judges, from St. Augustine down, does not seem to possess the value which people have naturally attributed to it. This expression seems in fact to have been adopted only as an indication of relative epochs, as the means of making understood and retaining the order and succession of things which were at once revealed. It is clear, indeed, that minute details categorically established by figures, which would satisfy the curiosity of a small number of men, would not be either received or comprehended by the vulgar, who, nevertheless, are entitled to this important instruction. We ourselves often resort to ways still more crooked to make ourselves better understood by all. It is in this way, for example, we speak of the rising and setting of the sun, to describe the arrival of this luminary to the meridian, to the solstice, etc., although we knew very well that we must attribute these phenomena to the inverse movements of the earth. According to geological observations, this common expression, days, ought to signify epochs, which embrace long periods of time, each being relative to a certain system of creation in which there were different formations of creatures, as well as successive extinctions of those previously existing. Each period began at a particular date, clearly determined and marked by a catastrophe which overturned the order of things anteriorly established on the earth. It was extended for a longer or shorter time, sometimes through succeeding epochs, and often up to the appearance of man himself. According to the conjectures of the scientific, an immense time elapsed between the formation of the first sediment and the last, without counting the period required for the consolidation and first cooling of masses of planetary matter. It was in long series of ages, which are but as instants in eternity, that the earth was fashioned, as we now behold it, by every kind of movement in the soil, by sedimentary deposits of different kinds, and finally prepared as the sojourning place of man, for whom God has disposed everything. End of Lesson 10.
Glossary, A through C, of Elements of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michelle. The Elements of Geology by William RUSCHENBERGER. Glossary, A through C. Abnormal, from the Latin ab, from, norma, rule, not conformable to rule. Abnormus, out of rule, misshapen. Acephalous, acephalous, from the Greek a, without, cephala, head, without a head, headless. Actinolite, from the Greek actin, a ray, lithos, a stone, a variety of hornblende, which usually occurs in fascicular crystals. There are 3 varieties of this mineral: crystallized, asbestos, and glassy. Aculeatus, Latin aculeate, having a sharp point. Acuminata, Latin acuminate, pointed, peaked. Acuta, Latin acute, sharp, pointed. Acuticosta, Latin acutus, pointed, and costa, rib, having pointed ribs or sides. Acutuloba, Latin acutus, pointed, loba, a lobe, having sharp or pointed lobes. Adult, from the Latin adolesco, I grow, full grown. Agate, from the Greek agathos, good, precious, an aggregate of certain silicious minerals, chiefly chalcedony, variously colored. Moss agate or mocha stone is a chalcedony containing within moss-like delineations of a yellowish brown or green color. Agglomerate, from the Latin agglomero, I wind up, to gather together. Agglomeration, a mass made up of parts gathered together. Agglutinated, from the Latin ad, to, gluten, glue, united together, adhering. Aliformis, Latin ala, wing, forma, shape, wing shaped. Albite, from the Latin albus, white, a mineral. Albitic, of the nature of albite. Algae, Latin, plural of alga, seaweed, systematic name of a family of plants. Alluvial, of the nature of alluvium. Alluvion, alluvium, from the Latin alluo, I wash upon. Gravel, sand, mud, and other transported matter washed down by rivers and floods upon land not permanently submerged beneath water. A deposit formed from transported matter. Alpine, belonging or relating to the Alps. Alumina, from the Latin alumen, alum, pure argil, the basis of alum, one of the earths. Aluminous, from the nature of alumina. Alveolatus, Latin alveolate, having the surface covered with numerous depressions, comparable to the alveoli or sockets of the teeth. Amblypterus, from the Greek amblis, obtuse, and pteron, wing, a fossil fish. Ambulacra, Latin, plural of ambulacrum, the narrow longitudinal portions of the sea urchin, the Echinus, which are perforated with a number of small orifices, giving passage to tentacular suckers, and alternate with the broad tuberculate spine-bearing portions. Ambulacrum, Latin, an alley. Ammonia, Latin, relating to Ammon, a name of Jupiter, specific name of a fossil shell. Ammonus, Latin, genitive case of Ammon, a name of Jupiter. Ammonite, from the Latin ammon. Amorphous, from the Greek a, without, morphe, form, shapeless. Amphibole, from the Greek amphibolus, equivocal. Amplexus, from the Latin amplecto, I embrace, generic name of a fossil. Ampullaria, from the Latin ampulla, a round swelled out bottle, name of a genus of snails. Amygdaloid, from the Greek amygdalon, an almond, and eidos, almond shaped, applied to certain rocks in which other minerals are occasionally embedded like almonds in a cake, a particular form of volcanic rock. Analogy, from the Greek ana, between, logos, reason, resemblance or relation things bear to each other, although not exactly alike in all respects. Analogous, having analogy or resembling. Analog, a substance or article having analogy to others may be called the analog of those things with which its properties or points of resemblance are comparable. Anenchites, a genus of fossil sea urchins. Andalusite, a mineral first observed in Andalusia in Spain. It is very hard and infusible, and consists chiefly of alumina and silica. Anfractuosity, from the Latin anfractus, the bending or winding of a way, an irregular hollow or groove. Anhydrous, from the Greek a, without, udor, water, without water, applied to salts and certain acids when deprived of water. Annular, from the Latin annulus, ring, shaped like a ring. Annularia, from the Latin annulus, ring, generic name of a fossil plant. Anodonta, from the Greek a, without, odous, genitive odulus, tooth, systematic name of a kind of muscle. Anodonte, plural of anodonta. Anoplotherium, from the Greek a, without, oplon, arm, or anoplos, unarmed, and therion, beast. Anticlinal axis, anticlinal line, from the Greek anti, against, Klinean, to incline, an imaginary line towards which strata, dipping in opposite directions, rise. Antiquatus, Latin, antiquated, out of date, abolished. Anthracite, from the Greek anthrax, charcoal, mineral charcoal, a kind of stone coal difficult to inflame. Anthracitiferous, from the Latin anthracite and the Latin fero, I bear, containing or affording anthracite. Opiocrinites, from the Greek apion, a pear, krinon, lily, the pear encrinite, a subgenus of fossil encrinites in which the stem is rounded and dilated at its upper part into a pyriform shape. Aquatic, from the Latin aqua, water, relating or belonging to water. Aquilina, Latin, of or like an eagle, rapacious. Araucaria, from Arauco, a district of Chile, fir trees with very rigid branches, having leaves like scales, either small and sharp pointed, or stiff, spreading, and lanceolate. The Norfolk Island pine is one of this genus. Arborescent, from the Latin arbor, a tree, branching like a tree. Arculata, Latin, arched, bent like a bow. Arenaceous, from the Latin arena, sand, sandy, of the nature of sand. Argil, from the Latin argilla, clay, which is formed from the Greek argos, white, because when pure it is white. Old name of alumina. Argillaceous, of the nature of clay. Argillaceous schist, clay slate or argillite. Argillite, a slaty rock of fine texture, with a faintly glistening or earthy surface of fracture, and mostly of a dark color. Roofing slate and novaculite or hone slate are varieties of argillite. Argillo-arenaceous, partaking of the nature of both clay and sand. Arietina, Latin, belonging or relating to a ram. Arkose, a name given to different metamorphic sandstones. Articulation, from the Latin articulus, a joint between bones. Asaphus, from the Greek asaphis, obscure, a name devised to express the obscure nature of a genus of trilobites, fossil crustaceans. Asbestos or asbestos, from the Greek asbestos, unconsumable, a fibrous soft mineral composed of easily separable filaments of a silky luster. It consists essentially of silica, magnesia, and lime. Astarte, name of a genus of fossil bivalve shells. Astrea, from the Greek aster, a star, a genus of Polyparia. Astraea, plural of Astrea. Athleta, specific name of a mollusk. Augite, from the Greek auge, luster, a mineral the same as pyroxene. Augitic porphyry, crystals of Labrador feldspar and of augite, in a green or dark grey base. Avalanche, mass of hardened snow detached from lofty mountains, which overturns everything in its way, often causing great destruction. Applied also to slides of earth and clay. Avicula, from the Latin avis, a bird, name of a genus of bivalve mollusks. Axis of elevation, line of elevation. Baxillar, from the Latin bacca, a berry, berry-like. Baculites, from the Latin baculum, a stick, a genus of tetrabranchiate cephalopods, the chambered shells of which are quite straight, but differ from those of the orthoceratites in having sinuous or undulated partitions with lobated margins. In this structure they are allied to the ammonites. Bagshot sand, a siliceous bed which overlies the London clay formation, corresponding in age with the Paris basin. Balani, plural of balanus. Balanus, Latin, a barnacle. Ballons, French, ballon, a ball. Rounded mountains are so called. A system of upheaval. Barranco, Spanish, a ravine. Basalt, a rock essentially composed of feldspar and augite, of a compact texture and dark green, grey, or black color. It occurs in columnar masses, one light colored with the feldspar predominating. It is sometimes called greystone. Basalt closely resembles greenstone. Basaltic, of the nature of basalt. Basset, outcrop or emergence of strata at the surface. Basterote, specific name of a fossil. Batrachian, from the Greek batrachos, frog, a kind of reptile resembling a frog in its mode of organization. Belemnites, from the Greek belemnon, a dart, a genus of fossil dibranchiate cephalopods, the shells of which are chambered and perforated by a siphon but internal. They are long, straight, and conical, and commonly called thunderstones. Bicordatus, Latin, bicordate, double heart shape. Bifurcated, from the Latin bis, two, furca, fork, divided into two branches. Bioculata, from the Latin bis, two, oculus, and eye, two-eyed. Bitumen, from the Greek pitos, the pitch tree, because it resembles pitch, a variety of inflammable mineral substances which, like pitch, is included under this term. Bitumenized, converted into bitumen. Bituminous, of the nature of bitumen. Bituminous shale, a slaty rock containing bitumen. Bivalve, from the Latin bis, two, valve, doors. Shells composed of two pieces united by a hinge are termed bivalves. Blende, sulphuret of zinc, a common shining zinc ore. Blumenbachii, the name of Blumenbach latinized. Beauce, French, a hillock, a rounded projection or elevation. Botryoidal, French, from the Greek botrus, a bunch of grapes, and eidos, resemblance. Clustered like a bunch of grapes, covered with smooth rounded masses. Brachiopod, from the Greek brachion, arm, pous, foot, a mollusk with a two-lobed mantle and bivalve shell. Brachyphylum, from the Greek brachus, short, phullon, leaf, a genus of fossil plants. Bradford clay, an English bed of the great oolite, usually consisting of a pale greyish clay containing a small portion of calcareous matter and enclosing thin slabs of tough brownish limestone. It abounds in fossil apiocrinites. Brash, a provincial word used in England to describe the alluvial mass or quantity of broken and angular fragments of subjacent rock, found usually between the vegetable mould and the regular rocks. It is also called rubble. Breccia, Italian, a rock composed of an agglutination of angular fragments. When the fragments are rolled pebbles, it constitutes a conglomerate rock called pudding stone. Brevifolia, Latin, from brevis, short, folium, leaf, short-leaved. Brongniarti, specific name of a fossil in honour of M. Brongniart, the eminent French naturalist. Buccinium, Latin, a trumpet or horn, name of a genus of mollusks. Bucci, the name of Von Buch latinized. Bucklandi, specific name of certain fossils given in honour of the eminent geologist Dr. Buckland. Buprestes, Latin, noxious insects, certain beetles. Calamites, from the Greek kalamos, a reed, common fossil plants in the coal strata. Calamites usually consist of jointed fragments, which are supposed to be portions either of the trunk or the branches of a plant, which appears from some of the larger specimens to have attained the dimensions of a tree. Both stem and branches are deeply ribbed along their whole length, and the ribs or furrows are crossed by horizontal rings at irregular intervals. Kalksinter, German Sintern, to drop, a German term for limestone deposited from springs and waters containing it, travertin. Calcar grosse, French, marine limestone. Calcar siliceaux, French, fresh water or silicious limestone. Calcareous, from the Latin calx, lime, containing lime. Calcareous grits, sandy beds intermixed with calcareous matter found in the oolite. Calceola, From the Latin, calceolus, a little shoe, a fossil bivalve shell. Calciferous. From the Latin calx, lime, fero, I bear, containing lime. Calcined. From the Latin calx, lime, converted into calx or a friable substance by the action of fire. Calcination. The reduction of bodies to a calx or friable condition by the action of fire. Calvus. Latin, bald. Specific name of a productus. Calimony. From the Greek kekalumene, concealed. A name of a genus of trilobites. Coniformis. Latin, from cana, a reed, formis, form, reed shaped. Canis. Latin, dog. Carbon. From the Latin carbo, a coal. The pure inflammable principle of charcoal. In its state of absolute purity, it constitutes the diamond. Carbonate. A compound of carbonic acid with a salifiable base. Carbonate of lime, for example, is a compound of carbonic acid with lime, constituting chalk, limestone, marble, etc. Carbonaceous. Belonging or relating to carbon. Carbonic acid. An acid compounded of carbon and oxygen. Carbonous. Of the nature of carbon. Carboniferous. From the Latin carba, a coal, fero, I bear, containing carbon. Carbonized. Converted into carbon. Carbonization. The action of forming or converting a substance into carbon. Carburet. A combination of carbon with a metal or other substance. Steel and black lead are carburets of iron. Carburetted. Converted into a carburet, containing carbon. Cardium. Latin, a cockle, a genus of bivalve shell. Carinata. Latin, from carina, a keel, carinate, having a keel-like elevation. Carnivora. Latin, carnivorous, carnivorous animals. Carnivorous. From the Latin caro, genitive carnis, flesh, voro, I eat, flesh-eating. Caryophilia. From the Latin caryophyllus, the garden pink, a genus of madrepora. Cascade. From the French, a cataract, a waterfall. Catena. A chain. Specific name of an ammonite. Catenated. From the Latin catena, a chain, linked together. Catapora. From the Latin catena, a chain, pora, pore, generic name of a polyp. Catulus or Catillus. Latin, a little dish, a genus of fossil shells. Caudatus. Latin, caudate, having a tail. Cavernous. From the Latin cavus, a hollow, containing hollows, excavated. Cemented. Joined together by cement. Cementation. When a solid body is surrounded by the powder of other substances, and the whole heated to redness, the process is termed cementation. Iron is converted into steel by cementation with charcoal. Centigrade. Thermometer. From the Latin centum, 100, gradus, a degree. Division into 100 parts. The scale of the centigrade thermometer is made by dividing the space between the points of freezing and boiling water into 100 parts or degrees. Cephalospis. Cephalospis. From the Greek cephala, head, aspis, shield, a genus of fossil fishes. Cephalopod. Cephalopod. From the Greek cephala, head, pous, in the genitive case, poudos, foot. A mollusk which has the head situated between the body and feet. Cerathea, plural of ceratheum. Ceratheum, a genus of turriculated univalve mollusks, both recent and fossil. Ceroid. From the Greek keros, wax, eidos, resemblance, wax-like. Cestration, French. From the Greek kestreos, name of a fish, a genus of the family of sharks. Cetacea. Latin, from the Greek ketos, a whale, name of an order of mammals. Cetaceae, plural of cetacea. Cetaceous, belonging or relating to Cetacea. Chalcedony, from the Greek chalcedon, Chalcedon, in Asia, where the finest specimens were originally found. A semi-transparent siliceous mineral, apparently found by the infiltration of siliceous matters in a state of solution. The chalcedonic varieties of quartz include chalcedony, chrysoprase, cornelian, sard, agate, onyx, cat's eye, flint, and hornstone. Chalk, from the German kalk, earthy carbonate of lime. Chalk has been discovered, it is said, for the first time in the United States in Alabama, 1845. Chalk marl, marl belonging to the Cretaceous formation. Kama, from the Greek kau, I gape, a cockle. Chara, origin of this word is unknown, a genus of aquatic plants. Chelonians, from the Greek chelone, a sea tortoise, animals of the tortoise tribe. Chert, a siliceous mineral resembling flint. It is usually found in limestone. Chlorite, from the Greek chloros, green, a soft green scaly mineral, slightly unctuous. Chloritic chalk, chalk containing chlorite. Chloritic schist, schist containing chlorite. Chrome, from the Greek chroma, color, the oxide of a metal called chromium. Oxide of chrome is green and furnishes a valuable color for porcelain. Chronology, from the Greek chronos, time, logos, discourse, the science which treats of the division of time and the order and succession of events. Cicatrices, plural of cicatrix. Cicatrix, Latin, a scar. Sidaris, Latin, a cap or turban, name of a genus of Echinidae. Cinders, matters remaining after combustion. Clavellata, Latin, from clavulus, a little nail, marked by little projections or points, knotted. Cleavage, the mechanical division, the laminae of rocks and minerals, to show the constant direction in which they may be separated. Clinkstone, see phonolite. Clymenia, from the Greek klumenon, the marigold, a genus of fossil cephalopods of the Devonian system, with a chambered shell analogous to that of the ammonite. Coal measures, the formation in which coal is found. Coccinelloides, from the Latin and Greek coccinella, cochineal, eidos, resemblance, resembling the cochineal insect. Cocosteus, name of a genus of fossil fishes. Coleoptera, from the Greek koleos, sheath, pteron, wing, name of an order of insects. Columba, Latin, a dove, specific name of a fossil shell. Columnar, Latin, columnar, in the form of a column. Coming today, when a vein or stratum crops out or appears on the surface, it is said to come to the day. Comminuted, fractured into small pieces. Communis, Latin, common. Comparative anatomy, the comparative study of the various parts of the bodies of different animals. Comptonia, a genus of plants named in honour of Henry Compton, Lord Bishop of London. Concentric, having a common centre. Concentricus, Latin, concentric. Conchiferous, from the Latin concha, shell, ferro, I bear, shell bearing. Conchylian, consisting of or containing shells. Condensable gas, any gas that is susceptible of being condensed into a fluid or solid. Conduit, a water pipe, a canal. Conformable stratification, when the strata are parallel to each other. Congeners, from the Latin con, with, genus, race, species belonging to the same genus. Conglomerate, from the Latin conglomera, I heap together, a rock composed of pebbles cemented together by another mineral substance, either calcareous, siliceous, or argillaceous. Conica, Latin, conical. Conifer, from the Latin conus, a cone, fero, I bear. A tree or plant which bears cones, such as pines, fir trees, etc. Conoidae, Latin conoidal, cone-shaped. Conoidal, from the Latin conus, a cone, and the Greek eidos, resemblance, cone-shaped, like a cone. Contemporaneous, from the Latin con, with, tempus, time, existing at the same time. Contorted, from the Latin con, together, torqueo, I twist, twisted together, bent. Coprolites, from the Greek kopros, dung, lithos, stone, fossil excrement. Coral, from the Greek koreo, I ornament, als, the sea, the hard calcareous support formed by certain polypi. Coral rag, certain beds of the middle oolite consisting chiefly of corals. Coralline, belonging or relating to coral. Coralloids, Latin, from coral, and the Greek eidos, resemblance, coral-like. Specific name of a Devonian fossil. Coringunum, Latin cor, heart, and gunum, snake-like. Specific name of a fossil. Cornbush, an oolite bed consisting of clays and sandstones. Its name is probably derived from the excellence of the cornland, which results from the decomposition of the limestones and their mixture with the sandstones and clay. Cornutus, Latin, horned. Coronata, Latin, crowned. Costatus, Latin, ribbed. Crocetella, a genus of bivalve shells. Crassus, Latin, thick. Crater, from the Latin, crater, a great cup or bowl, the mouth of a volcano. Crater form, in the form of a crater. Crenatum, Latin, crenate, having rounded teeth. Cretaceous, from the Latin creta, chalk, of the nature of chalk, relating to chalk. Crinoidae, from the Greek krinon, lily, eidos, resemblance, a family of radiate animals. Crioceratites, from the Greek kyros, a ram, and kyros, a horn, a fossil cephalopod. Crises, plural of crisis. Crisis, Greek, the point of time when any affair comes to its height. Crocodilian, any animal of the tribe of crocodiles. Crop out, when a rock in place emerges on the surface of the earth, it is said to crop out. Crustacean, any animal of the class of Crustacea, a crab. Cryptogamia, from the Greek kryptos, concealed, gamos, marriage, name of a class of plants. Crystal, from the Greek krystallos, ice. This term was originally applied to those beautiful transparent varieties of silica or quartz known under the name of rock crystal. When substances pass from the fluid to the solid state, they frequently assume those regular forms which are generally termed crystals. A crystal is any inorganic solid of homogeneous structure, bounded by natural planes and right lines symmetrically arranged. Crystalline, relating to or resembling crystals. Crystallization, the process of forming crystals. Ctenoidians, from the Greek kteis, in the genitive kteois, a comb, an order of fishes. Cucullatus, Latin, hooded. Cuprous, belonging to copper. Cuvieri, the name of Cuvier latinized. Cyathocrinites, from the Greek koathos, a cup, krinon, lily, a genus of crinoidae. Cyathophila, plural of cyatophyllum. Cyatophyllum, from the Greek koathos, a cup, phyllum, a flower, a genus of Polyparia. Cycadae, from cycas, one of the genera, an order of plants. Cycas, a name employed by the ancients to designate a little palm. Cyclades, plural of cyclus. Cyclus, from the Greek kuklos, a circle, a genus of gasteropods. Cycloidians, from the Greek kuklos, a circle, An order of fishes. Cymbium. From the Greek kumba, a boat. Specific name of a shell. Cypraea. From the Greek kupris, Venus. A genus of gastropod mollusks. Cypris. From the Greek kupris, Venus. A genus of crustaceans. Sirena. A genus of bivalve mollusks. End of glossary A through C. Glossary D through L of Elements of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michelle. Elements of Geology by William RUSCHENBERGER. Glossary D through L. Data. From the Latin datum, given, a gift. Admitted facts. Debacle. French. Sudden escape of water from a lake following a bursting of its barrier. Debris. French. Wreck, ruins, remains. Defranchi. The name of de France, Latinized. Degrade. From the Latin de, primitive, gradus, step, degree. To lessen, to cut down. Degradation. The act of lessening, reduction. Dejections. Matters evacuated from the bowels. Deltoide. Latin. From the Greek letter delta, eidos, resemblance. Resembling a delta. Dentatum. Latin. Dentate. Having sharp teeth. Denude. From the Latin denudo, I strip, to lay bare. Denudation. A removal of a part of the land so as to lay bare the inferior strata. Deposition. From the Latin depono, I let fall. The falling to the bottom of matter suspended or dissolved in water or other liquid. Depressus. Latin. Pressed, sunk. Deus. Latin. God. Diadema. Latin. A diadem, a crown. A genus of Echinidae. Diagram. From the Greek dia, through, grapho, I write. A figure drawn for illustration. Diallage. From the Greek diallage, difference. A mineral of foliated structure easily divisible in one direction. Its natural joints and fractures exhibiting a very different lustre and appearance. Diceras. From the Greek dis, two, keras, horn. Generic name of a fossil bivalve. Dicotyledons. From the Greek dis, two, kotulidon, seed lobe. A division of plants according to the natural order. Dicotyledonous. Relating to dicotyledons. Digona. From the Greek dis, two, gona, angle, having two angles. Dilatata. Latin. Dilated, swelled out. Diluvial. Relating to diluvium. Diluvion, diluvium. From the Latin diluo, I wash away, a superficial deposit. Dinotherium. From the Greek dinos, circular, therion, a beast. Diorite. A variety of trap rock consisting of albite and hornblende. Dip. Direction of the inclination of strata. To take a dip is to measure the degree that a stratum inclines or dips from a horizontal line. Direction of strata. The strike, or line of bearing. Disaggregated. From the Latin de, privative, aggregero, I gather together. Separated, divided, broken up. Disaggregation. The breaking up of a mass into small parts. Discordant stratification. Unconformable stratification. Disengaged. Separated from, freed. Disintegrate. From the Latin de, privative, integer, entire, whole. To separate or break up an aggregate into parts. Disintegration. The act of separating or dividing a whole into parts. Dislocate. From the Latin de, privative, locus, place, to put out of place. Dislocation, displacement of a part. Disposition, from the Latin dispono, I arrange, arrangement, method, order. Disruption, from the Latin disrumpo, I break off, the act of breaking asunder. Distortion, from the Latin de, from, tortum, twisted, the act of distorting or twisting out of place. Dolichos, gyrus, Latin, from the Greek, dolichos, long, diere, neck, long necked. Dolomite, named after Dolomieu, magnesium marble, granular magnesium carbide of lime. It contains about 45% of carbonate of magnesia. It is commonly more friable or crumbling than pure limestone, and less durable as a building material. Dolomization, the conversion of common into magnesium limestone or dolomite. Dome, from the Latin domus, house, a rounded projection. Domite, a trachytic rock. Dunes, French, downs. Duvalli, name of Duval Latinized. Ubulation, the act of boiling. Echinidae, echinidae, from the Greek echinos, a hedgehog, eidos, resemblance, systematic name of the order of sea urchins. Echinoderms, from the Greek echonos, a hedgehog, derma, skin, a class of invertebrate indentate, an order of mammals without teeth. Indentate, from the Latin a, without, dens, tooth, without teeth. Effervescence, from the Latin effervesco, I grow hot, the commotion produced in fluids by the sudden escape of gas in the form of bubbles. Effusion, from the Latin effundo, I pour out, the pouring out of a liquid. Elegans, Latin elegant. Emboss, from the French bosse, a protuberance, to cover with lumps or bunches. Encrinites, from the Greek krinon, a lily, a genus of echinoderms. Entomostrecans, from the Greek entomos, incised, ostrakon, a shell, a division of the class of Crustacea. Epidemic, from the Greek epi, upon, demos, the people, a prevailing disease. Epoch, the time from which dates are numbered. Equalis, Latin, equal. Equation, from the Latin aequare, to equal, equivalent, a mean proportion between extremes. Equilibrium, from the Latin aequa, equality, libro, I balance, equal balance. Aquesta, plural, equestum. Equestaceae, from equestum, one of the genera, a natural order of plants. Equestum, from the Latin equus, horse, seta, hair, a genus of plants. Erode, from the Latin erodo, I gnaw, to wear away, to corrode. Erosion, the act of wearing away. Erosive, corroding, wearing. Eruption, from the Latin from, rumpo, I burst, the act of bursting from any confinement. Escarpment, from the Italian escarma, escarpment, from the Italian scarpa, sharp, formed from the Latin carpere, to cut or divide. The steep face often presented by the abrupt termination of strata where subjacent beds crop out from under them. Escaroides, from the Greek escara, a fireplace, a gridiron, eidos, resemblance, specific name of a coral. Euphotide, a rock composed essentially of feldspar and diallage. Evolutus, Latin, unfolded. Excoriation, from the Latin ex, from corium, skin, an abrasion, mark of a part having been rubbed from the surface. Exogyra, from the Greek exo, without, gyros, circle, not circular. A genus of unimuscular bivalves, allied to the oyster. Explosion, a sudden bursting with noise and violence. Extremities, the limbs, legs, arms, etc. Exudation, from the Latin ex, from, sudo, I sweat, transpiration. Exuviae, Latin, the sloths or caskins or shells of animals. Fasciculus, Latin, plural of fasciculus. Fasciculus, Latin, a bundle. Fascigiata, Latin, sharpened at top like a pyramid. Fathom, a measure of 6 feet. Fault, from the German fall, an accident, sinking, fall. Fauna, from the Latin faunus, the name of a rural deity among the Romans. All animals of all kinds peculiar to a country constitute the fauna of that country. Fecit, Latin, he made. Feldspar or felspar, from the German feldspath, an important mineral composed of silica, alumins, and potash, with traces of lime and often of oxide of iron. It enters into the composition of granite. Feldspathic, of the nature or belonging to feldspar. Felis, Latin, a cat. Phenionis, specific name of a fossil zamia. Ferruginous, from the Latin ferrum, iron, containing iron. Ficoides, from the Latin ficus, a fig tree, and the Greek eidos, resemblance, specific name of a fossil plant. Firmamentum, Latin, the firmament. Fissile, from the Latin findo, I split, easily split. Fissure, a crack, a separation, a split. Flora, from the Latin flora, goddess of flowers. All the plants of all kinds of a country constitute the flora of that country. Fluviatile, bringing or relating to a river. Foliatia, Latin, foliated. Foliated, from the Latin folium, a leaf, in form of leaves, leafy. Foraminifera, from the Latin foramen, hole, fero, I bear, name of a tribe of minute shells. Formation, any group of rocks formed during a particular epoch, or of common origin. Fossil, from the Latin fodio, I dig, any organic body or the traces of any organic body, whether animal or vegetable, which has been buried in the earth by natural causes. Fossiliferous, containing fossils. Fossilized, converted into a fossil. Fulcrum, Latin, a prop, the fixed point on which a lever moves. Fumihole, French, subterraneous emissions of hydrogen gas in consequence of the ebullition of certain sulphurous waters, the hole or orifice through which the gas escapes. Fumes, vapours. Fusion, the act of melting, state of fusion is being melted. Fusiform, Latin, fusiform, spindle shaped. Galena, from the Greek galena, lead ore, sulphuret of lead, that is, a compound of sulphur and lead. Ganoidians, an order of fishes. Garnet, a mineral consisting of silicates of alumina, lime, iron, and manganese. There are several varieties of this mineral. Garnet occurs embedded in mica slate, granite, and gneiss. and occasionally in limestone, chlorite slate, serpentine, and lava. Gas. From the German Geist, spirit. The name given to all permanently elastic fluids or airs different from the atmospheric air. Gaseous. Of the nature of gas. Gault. A kind of clay. Gelatinous. Jelly-like. Genera. Latin, plural of genus. Generic. Relating to genus. Genus. Latin. A kindred, breed, race, or family. Geodes. From the Greek geodes, earthy. Nodules of ironstone hollow in the centre. Rounded pebbles having an internal cavity lined with crystals are also so called. Geogeny. From the Greek ge, the earth, geonomy, I beget. Science embracing the theories of the formation of the entire universe. Geognostic. Relating to geognosy. Geognosy. From the Greek ge, the earth, gnosis, knowledge. Knowledge of the mineral substances which constitute the mountains and strata of the earth. Geological. Relating to geology. Geologist. One skilled in geology. Geology. From the Greek ge, the earth, logos, discourse. That branch of natural history which treats of the structure of the terrestrial globe. It is divided into descriptive geology, dynamic geology, which treats of the forces by which the surface of the earth has been modified, practical and economic geology, embracing the application of geological science to mining, road making, architecture, and agriculture. Geysers. From an Icelandic word signifying raging or roaring. Celebrated spouting fountains of boiling water in Iceland. Gibbosite. From the Latin gibba, a bunch, a protuberance. Giganteum giganteus. Latin, gigantic. Glabrer. Latin, smooth, bald, bared. Glaciers. French. Masses or beds of ice formed in high mountains, derived from the snows or lakes frozen by the continued cold of those regions. Globata. Latin, globate, rounded. Gneiss. German, a rock resembling granite in its constitution and general characters, but it contains more mica and the colors are banded, but owing to the arrangement of the minerals, especially the mica, in parallel planes. In consequence of this structure the rock splits into coarse slabs along the planes of the mica, besides having the cross fracture or cleavage of granite. It is often described as a stratified or stratiform granite. A rock intermediate between granite and gneiss is called gneissoid granite. Gneiss is used for building and flagging. Goodhalley. The name of Goodhall Latinized. Gralliae. Latin, wading birds. Granite. A crystalline aggregate of quartz, feldspar, and mica. The ingredients of granite vary in their proportions, and the rock is described as micaceous, feldspathic, or quartzone, according as mica, feldspar, or quartz is the predominating mineral. It is called porphyritic granite when the feldspar is uniformly disseminated in large crystals. They appear like white blotches, often of a rectangular shape, over a worn surface of the rock. Granitic. Belonging or relating to granite. Granular. Consisting of grains. Graphite. From the Greek grapho, I write. A mineral composed of carbon and iron, constituting carbonate of iron. It is known as plumbago and black lead. It is used in the manufacture of lead pencils. Grauwacke and Greywacke. German. Grey rock. A name given to some of the older shales in the geological series, and also to the sandstones that accompany them. Gravel. Small rounded stones varying in size from a small pea to a walnut or something larger. Gravitate. From the Latin gravis, heavy. To tend towards the centre of the earth, as all bodies do from their weight. Greensand. A formation of the Cretaceous group. Greenstone. A tough variety of trap rock, consisting chiefly of hornblende. Gris bigarre, French. A fine-grained solid sandstone, sometimes white, but more frequently of a red, blue, or greenish colour. It is the same as bunter sandstein. Grit, a coarse-grained sandstone. Grunstein, German, greenstone or diorite. Gryphia, from Greek grupos, incurved. A genus of fossil bivalves. Gryphites, generic synonym of the Productus oculatus. Gryphite limestone, a marl, so called from containing gryphia. Gryphotenkalk, German, a name sometimes given to zechstein. Gymnospermous, from the Greek gumnos, naked, sperma, seed, having naked seeds. Gypseous, of the nature of gypsum. Gypsum, native sulphide of lime. The transparent varieties constitute selenite, and the fine mass of alabaster. Gypsum is converted into plaster of Paris by heat. Hamites, from the Latin hamus, a hook, a genus of extinct cephalopods, inhabiting chambered shells, losing their spiral form after their commencement, and then continued for a considerable extent with a single bend on themselves like a hook. They are found in the greensand of England. Helices, plural of helix. Helix, Latin, a snail. Heterocercal, from the Greek heteros, opposite, kerkos, a tail, having the spine prolonged into the tail. Heterophylla, from the Greek heteros, opposite, phyllum, leaf, specific name of a fossil plant. Hibberti, name of Hibbert, Latinized. Hieroglyphics, from the Greek eros, sacred, glupho, I write, sculpture or scripture writing. Hipparites, from the Greek hipparis, horsetail, a certain fish, a genus of extinct mollusks supposed to be bivalve. The principal valve is of a subcylindrical or elongated conical form, traversed by one or more internal longitudinal ridges, enclosed by a small subcircular valve like an operculum. Hippopotami, Latin, plural of hippopotamus. Hippopotamus, from the Greek hippos, horse, potamus, a river, the river horse. Holoptychus and Holotychus, from the Greek olos, the whole, tukios, folded. A fossil fish of the ganoid order, the enamelled surface of whose scales was marked by large undulating furrows. It had sharp conical teeth. Homocercal, from the Greek omos, joined, kerkos, a tail. Applied to the tail appended to the termination of the spine, as in most of the fishes now existing. Hornblende, a mineral of dark green or black colour, abounding in oxide of iron and entering into the composition of several of the trap rocks. There are three varieties: common, hornblende schist, and basaltic hornblende. Hornblende schist, a slaty variety of hornblende. Humus, Latin, moist earth, vegetable earth or mould. Humerus, Latin, shoulder, name of the bone placed between the shoulder and elbow. Hybodones, from the Greek ubos, bent outwards, and odos, tooth, a division of the shark family. Hydrated, from the Greek udor, water, containing water. Hydrochloric acid, an acid composed of hydrogen and chlorine, formerly known as muriatic acid. Hydrostatics, from the Greek udor, water, and stio, I stand, the science which explains the properties of the equilibrium and pressure of liquids. Hypersthene, Labrador hornblende. It contains iron, silica, and magnesia. Hypersthene rock differs from common hornblende only in its foliated crystallization and its pearly or metallic pearly luster. It is a very tough rock with a structure resembling gneiss. Hypnoides, from the Greek upnon, a sort of moss, eidos, resemblance, specific name of a fossil plant. Hypogeny. From the Greek upo, under, geonome, I am formed. A class of rocks which have not assumed their present form and structure at the surface of the earth, but are apparently of igneous origin and thrust up from below. Hypothesis. From the Greek upo, under, and tithemi, I place. A theory or supposition, a rational conjecture. Hypothetical. Of the nature of hypothesis. Ichthyosaurus, the fish lizard. Igneous. From the Latin ignis, fire. Relating or belonging to fire. Iguanodon. From iguana and the Greek odos, tooth. An extinct genus of gigantic herbivorous reptiles, discovered in the south of England. Imbricatoria. Latin, as if imbricated or tile-like. Imbricata. Latin, imbricate, tile-like, arranged like tiles. Impressa. Latin, impressed, engraved, marked. Inequivalvus. Latin, inequivalve, having unequal valves. Incandescence. From the Latin incandescere, to grow very hot, to be inflamed. The condition of great heat, showing a certain light, as if the heated substance itself were burning. Melted. Incandescent, greatly heated. Incoherent. From the Latin in, not, con, with, hearo, I adhere. Loose, wanting cohesion. Inclination of beds, dip. Incrustation. From the Latin crusta, a crust. A covering like a crust. Inequilateral. From the Latin inequalis, unequal, latus, in the genitive lateris, side. Having unequal sides. Infiltration. From the Latin filtrare, to filter. The act of filtering through, producing an accumulation of liquid. Inoceramus. From the Greek en, with, keramos, earthenware. A genus of bivalve fossil shells, which are chiefly characterized by their hinge and the fibrous structure of their constituent substance. The shell, in consequence of the vertical arrangement of the fibres, readily breaks into pieces, and it is often extremely difficult to extricate a specimen with the hinge and beaks tolerably entire. In place, in their original position, where they were formed. Inquinata. Latin, stained, dirty. Inserted, attached. In situ. Latin, in place. Intercalated. From the Latin intercalo, I place between, placed between. Intercalation. The placing one substance between others, as one stratum between two others. Interposed. From the Latin inter, between, pano, I place, placed between. Intertropical, between the tropics. Intrusion. The act of thrusting or forcing in. Isolated. From the Italian isola, an island, separated like an island. Isothermal. From the Greek isos, equal, therma, heat. Isothermal lines are those which pass through those points on the surface of the earth at which the mean annual temperature is the same. Jasper. A siliceous mineral of various colors. Jurassic. Belonging to the Jura Mountains. Cooper. German. The upper portion of the new red sandstone formation. Cooper-Schiefer. German. Copper slate. Labradorite. Labrador spar. It consists of silicate of alumina, lime, and soda, with traces of oxide of iron. It is a variety of feldspar. Labyrinthica. Latin, labyrinth-like. Labyrinthodon. From the Greek labyrinthos, a labyrinth, odos, tooth. An extinct genus of batrachians, characterized by teeth of a peculiarly complicated structure. The remains of this genus peculiarly characterize the Cooper formation in Germany and the corresponding sandstones in England. Lacustrian. From the Latin lacerta, a lizard. Any animal of the lizard tribe. Lacustrine. From the Latin lacus, a lake, belonging or relating to lakes. Laevis. Latin. Smooth, bare, bald. Lamanonis. Specific name of a fossil plant. Lamberti. The name of Lambert latinized. Lamina. Latin, plural, laminae, a plate. Landslip or landslide. The removal of a portion of land down an inclined surface, from its attachment being lessened by the action of water beneath, or by an earthquake. Lapilli. From the Latin lapillus, a little stone. Small volcanic cinders. Lateralis. Latin, lateral. Lava. The substances which flow in a melted state from a volcano. Lavas vary in consistence and texture. Lenta. Latin. Slow, heavy, stupid. Lepiodendra. Plural of lepiodendron. Lepiodendron. From the Greek, lepis, scale, dendron, a tree. A genus of fossil plants having a scaly bark. Leptena. A synonym of the genus Productus. Leimeri. The name of Leimeri latinized. Ligneous. From the Latin lignum, wood, woody, of the nature of wood. Lignite. From the Latin lignum, wood, a kind of coal. Lima. Latin. A file, name of a genus of bivalve. Linearis. Latin. Linear, line-like. Line of bearing, strike. Liquefaction. The act of becoming liquid. Lithoites and lituites. From the Latin litus, a crooked staff. Fossil chambered shells, curved or bent at one end. Lithographic. From the Greek lithos, stone, grapho, I write. Lithographic stone, used for the purposes of lithography. Lithophagy. From the Greek lithos, stone, phrago, I eat. Small worms found in slate which give it a red color. Littoralis. Latin. Littoral. Belonging or relating to the shore. Loam. A mixture of sand and clay. Loess. A German geological term applied to a tertiary alluvial deposit which occurs in patches between Cologne and Basel. The term is applied by the English to that particular yellow loam with calcareous concretions. Longirostris. Latin. From longus, long, rostrum, beak, long billed. Longiscata. Latin. A little longer. Lycopodiaceae. From the Greek lukos, a wolf, pous, foot. A natural order of plants which includes the lycopodium. Laeli. The name of Lyell latinized. Limnea or Limnea. From the Greek limne, a pool. A genus of freshwater snails. Lusum. Latin. Light. Lugdunensis. Latin. Belonging or relating to Leon. End of section 21. Glossary D through L. Glossary M through Z of Elements of Geology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Michelle. Elements of Geology by William Ruschenberger. Glossary M through Z. Madrepora. Latin. Compound of the French madre, spotted, and Latin porus, pore. A genus of corals. Madrepore. A kind of coral. Madreporic. Of the nature of madrepore. Magnesia. A white, tasteless, earthy substance. Magnesian. Relating to or containing magnesia. Magnesian limestone. Limestone which contains magnesia. An extensive series of beds lying above the coal measures. Magnetic. Having the properties of the magnet or lodestone. Magnum. Latin. Great. Mammal. Any animal that suckles its young. Mammaliferous, containing mammals. Mammillary, from the Latin mammilla, a little nipple, studded over with small rounded projections. Mammoth, an extinct species of elephant. Mantellia, a genus of fossil Cycadae, named in honour of Mr. Mantell. Margaritifera, from the Latin margaritum, a pearl, fero, I bear, pearl bearing. Marine, from the Latin mar, the sea, relating to the sea. Marl, argillaceous carbonate of lime. There are several varieties of marl. Marshy, the name of marsh latinized. Marsupial, from the Latin marsupium, a pouch. Any animal having a peculiar pouch in front or on the abdomen. Mastodon, from the Greek mastos, a nipple, odos, tooth. A genus of extinct quadrupeds allied to the elephant. Matrix, Latin, the stony substance in which metallic ores and crystalline minerals are embedded. Maximum, Latin, greatest. Meandrina, a genus of polyps. Meandrinae, plural of meandrina. Medicaginella, specific name of a chara, a kind of fossil moss. Medullary rays, from the Latin medulla, marrow. The vertical plates of cellular tissue which radiate from the centre of the stem through the wood to the bark in exogenous plants. Megalixus, from the Greek megas, great, ixus, fish. An extinct genus of fishes, including species of great size. Megalodon, from the Greek megas, great, odous, tooth. A genus of peculiar fossil bivalve shells. Megalonyx, from the Greek megas, great, onyx, a claw. A large fossil mammal found in Virginia. Melania, from the Greek melos, black. A genus of fluviatile univalves. Mellophyre and Mellophyra, from the Greek melos, black. A kind of porphyry, the constituents of which are united by a black cement. Mephitic, French, Mephitis, the goddess of foul smells, applied to impure or foul exhalations. Metalliferous, containing metal. Metamorphic, relating to metamorphism. Metamorphism, from the Greek meta, indicating change, morpha, form. Metamorphosis, plural of metamorphosis. Metamorphose, change of form. Mica, from the Latin mico, I shine. A mineral generally found in thin elastic laminae, soft, smooth, and of various colours and degrees of transparency. It is one of the constituents of granite. Micaceous, of the nature of mica. Mica schist, mica slate. Microscope, from the Greek mikros, little, skopeo, I view. An optical instrument which enables us to examine objects too small to be seen by the unassisted eye. Microscopic, minute, perceivable only by aid of a microscope. Miliolites, or miliola, from the Latin milium, a millet seed, and Greek lithos, stone. A genus of foraminiferous fossil shells found in the neighbourhood of Paris. Millstone grit, coarse grained quartzose sandstone. Mine, German, any subterraneous work or excavation which has for its object the extraction of any mineral products, as metallic ores, coal, etc. Mineral, any inorganic natural object, whether solid, liquid, or gaseous. Mineralogy, that branch of natural science which treats of the properties of minerals. Minima, minimum, Latin, least. Minus, Latin, little. Minuta, Latin, minute, very small. Mollusc, French, a fine grained sandstone, usually soft and loose, but sometimes sufficiently hard for building purposes. Mollusk, from the Latin mulus, soft.
Any animal of the class of mollusca. Monile, Latin, belonging or relating to a necklace. Moniliformis, Latin, from monile, a necklace, forma, form, in form of a necklace. Monocotyledons, from the Greek, monos, single, cotyledon, seed lobe, a class of plants having but one seed lobe in the embryo. Moraines, longitudinal deposits of stony detritus found at the bases and along the edges of all the great glaciers. Mucronatus, Latin, pointed, sharp pointed. Multilocular, from the Latin multus, many, loculus, a partition, having many chambers or partitions. Mural, from the Latin muros, a wall, belonging or relating to a wall. Murex, Latin, a shellfish, a genus of univalve mollusks. Muricata, Latin, full of sharp prickles or points. Muscle, an organ of motion, the flesh of animals. Mussel, a bivalve mollusk. Mutable, Latin, mutable, changeable. Maya, a genus of bivalve mollusks. Nagelfluh, German, a coarse conglomerate. Nautilus, a genus of cephalopods. Navicula, Latin, a little boat. Neocomian and Neocomin, French. The lower beds of the Cretaceous system in the south of France and elsewhere are described by the French geologists under this name. Neptunian, from Neptune, god of the sea, belonging or relating to water. Neurenia, a genus of fossil univalves resembling both Cerithium and Turritella.
Nervures,
Veins of leaves, also the tubes for expanding the wings of insects. Neuroptera, from the Greek, neuron, a nerve, petron, wing, an order of insects. Neuropterus, a genus of fossil plants. Nidiformis, Latin, in the form of a bird's nest.
Nilsonia,
A genus of fossil plants.
nodosus,
Latin, knotty. Nodule, from the Latin, nodus, a knot, a rounded irregular lump or mass. Normal, from the Latin norma, a rule, according to the peculiarities of a family or genus, without the least departure. Norwich or Norfolk crag, a tertiary formation which rests on the London clay or chalk and includes marine shells. Nucleus, Latin, a kernel, the solid core of a body. Nucula, from the Latin nux, a nut, a genus of bivalve shells with numerous teeth like those of a comb. Nummulites, from the Latin nummus, money, and from the Greek lithos, stone, fossil money, an extinct genus of cephalopods of a thin lenticular shape, divided internally into small chambers. Nummulite limestone obtains its name from the presence in it of these shells in great abundance. In Alabama there is a mountain range entirely composed of one species of nummulite. Nutrition, the animal function by which the various organs receive nutritive substances, previously prepared by the several organs of digestion, necessary to repair their losses and maintain their strength. Oblongus, Latin, oblong. Obovata, Latin, obovate. Obovate, from the Latin ob, for opposite, ovum, egg, reverse of ovate or egg shaped. Obsidian, named after Obsidius, a glassy lava, volcanic glass. It consists of silica and alumina with a little potash and oxide of iron. Octoplicata, Latin, octo, 8, plicata, folded, having 8 folds. Oolite, from the Greek, oon, an egg, lithos, stone. A granular variety of
carbonate of lime.
frequently called rowstone,
Oolitic,
belonging or relating to oolite. Opalescent, resembling opal, a beautiful mineral characterized by its iridescent reflection of light.
Operculum, from the Latin operio, I cover, the lid which protects the gills of fishes and closes the opening of certain univalve shells. Orbicularis, Latin, orbicular. Orbit. From the Latin orbis, a circle. The circular cavities in which the organs of vision are lodged are named the orbits. Ores. From the German Erze, mineral bodies from which metals are extracted. Organ. From the Greek organon, an instrument, part of an organized being, destined to perform some particular function. The ears are organs of hearing, the muscles organs of motion, etc. Organic. Relating to organs. Organized. Possessing organs. Organization. A mode of structure. Organisms. Latin, from the Greek organo, I arrange, or provide with organs, organizing or constructing. Orthis. A genus of fossil bivalve shells. Oscillation. From the Latin oscillum, an image hung on ropes and swung up and down in the air. The act of moving backwards and forwards like a pendulum. Oscillatory. Swinging backwards and forwards like a pendulum. Ostracea. Family of bivalves which includes the oyster. Ostrea. Genus of bivalves, an oyster. Outcrop. The emergence of a rock in place at the surface. Outlier. A hill or range of strata occurring at some distance from the general mass of formation to which it belongs. Ovatus. Latin, ovate, egg-shaped. Overlying. When one stratum lies over or overlaps another, it is said to be overlying. Oxide. From the Greek oxus, acid, eidos, form. A compound which is not acid, containing oxygen. Oxygen. From the Greek oxus, acid, genein, to generate, vital air. Pachyderma. Latin, from the Greek pacos, thick, derma, skin, thick skinned.
Pachydermata. Latin, pachyderms. Pachyderms. An order of quadrupeds including the elephant, horse, pig, etc., distinguished by the thickness of their hides. Pachydermatus. Relating to pachyderms. Pachynatus. Latin, from the Greek pachos, thick, gnathos, jaw. Specific name of the labyrinthodon. Paleontologist. One skilled in paleontology. Paleontology. From the Greek paleos, ancient, on, creature, logos, a discourse. That branch of zoological science which treats of fossil organic. Paleozoic. Relating to ancient life. Palmacites. A genus of fossil plants. Paulundina. From the Latin paulus, a marsh. A genus of freshwater gastropods. Paulundinae. Plural of Paulundina. Paulundine. Belonging to a marsh. Parallel. Extended in the same direction and preserving always the same distance. Parallelism. The state of being parallel.
Parallelepiped.
A solid contained by 6 planes, 3 of which are parallel to the other 3.
Parasite. An adherent, a hanger-on. Parasitic. Of the nature of a parasite. Parietes. From the Latin paries, a wall. The sides are parts forming an enclosure. Pecopterus. From the Greek pekos, sheepskin, pteris, a fern. A genus of fossil ferns. Pecten. Latin, a comb. A genus of bivalve mollusks. Pectinata. Latin, pectinate. Like the teeth of a comb. Pellicle. From the Latin pellis, a skin. A thin skin or crust. Pennine formation. New red sandstone. Pentamerus or pentamerus. From the Greek pente, 5, meros, apart. Pentangulatus. Latin, having 5 angles. Percolate. From the Latin per, through, colo, I strain. To strain or drip through. Peridot. Prismatic chrysolite. Perlite. Pearlstone. A gray variety of obsidian. Permanent gas. Any gas which remains in the aeriform state under ordinary circumstances. Peroxide. The highest degree of oxidizement of which a metal or other substance is susceptible without becoming an acid. Pespelicani. Latin, pelican foot. Phanerogamia, from the Greek, phaneros, evident, gamos, marriage. The division of the vegetable kingdom, in which all the plants bear flowers and are multiplied by means of true seeds. Phanerogamous, belonging or relating to the phanerogamia. Phenomena, plural of phenomenon. Phenomenon, Greek, appearance, visible quality, event. Pholos, from the Greek, pholos, a lurking place. A genus of mollusks. Pholades, plural of pholas. Pholodomia, a genus of mollusks. Phonolite, clinkstone, a species of compact basalt which is sonorous when struck. Phosphoric, phosphorescent, from the Greek phos, light, emitting light in the dark. Pistiliformis, Latin, in the form of a pistil. Placunea, Latin, from the Greek plakois, broad, flat, even. Plagiostoma, from the Greek plagios, oblique, stoma, mouth, a genus of bivalve mollusks. Planorbis, from the Latin planus, flat, orbis, a circle, a genus of marsh snails. Planos, Latin, flat. Plaster of Paris, a substance prepared by heating gypsum. Plateau, French, an elevated plain or tableland. Plateau, plural of plateau. Platina or platinum, from the Spanish plata, silver, on account of its color, a metal of whitish color, exceedingly ductile, malleable, and of difficult fusion. Pleistocene, from the Greek pleistos, the most, kainos, recent, the newest Pliocene formation or newest tertiary. Pleuronectes, from the Greek pleura, side, nectes, swimmer, a genus of fishes. Pleurotoma, from the Greek pleura, side, toma, a notch, a genus of univalve mollusks having a notch in the side of the shell.
Pleurotomaria, a tribe of mollusks. Plicatula, from the Latin plica, a fold, a genus of mollusks. Plutonic, after Pluto, the god of fire, relating to fire. Poikilotic, from the Greek poikilos, variegated, a name applied to the new red sandstone formation in consequence of the varieties of colours it exhibits. Polyp, from the Greek polos, many, pous, foot, a radiated animal which has a cylindrical or oval body or sac with an opening at one extremity around which are long feelers. Polyparia and Polypiaria, groups of polyps or animalcules which form coral. Polyparium, the skeleton or framework formed by coral animalcules. When this framework is of a stony hardness, it constitutes coral. In fossils, the polyparium alone remains. Porous, containing pores. Porphyric, of the nature of porphyry. Porphyroid, resembling porphyry. Porphyry, from the Greek porphyra, purple, originally applied to a red rock found in Egypt, a compact feldspathic rock containing disseminated crystals of feldspar, the latter when polished forming small angular spots of light color thickly sprinkled over the surface. The rock is of various colors, dark green, red, blue, black, etc. Porrecta, Latin, extended. Pozzuolana and Pozzuolani, volcanic ashes used in the manufacture of mortar which hardens under water, exported from Pozzuoli near Naples. Precipitation, the action by which a body abandons a liquid in which it is dissolved or suspended and becomes deposited at the bottom. Prismaticum, Latin, prismatic. Productus, a genus of extinct mollusks. Pterodactyly, Latin, plural of pterodactylus. Pterophyllum, from the Greek, pteron, wing, phyllum, leaf, a genus of fossil plants. Pudding stone, conglomerate. Pumice, vesicular obsidian. Pyrites, a compound of sulphur and iron. Pyroxenic, of the nature of pyrocene. Quadersandstein, German, the lower Cretaceous beds in Germany, any sandstone fit for building purposes. Quaquaversal, turning each way. Quarry, a stone mine, a place where stones are dug. Quartz, German, rock crystal, a constituent of granite and some other rocks. Quartzose, of the nature of quartz. Radiata, Latin, radiate, the name of a class of zoophytes. Radiate, from the Latin radius, a ray, furnished with rays. Radius, Latin, a ray, the semi-diameter of a circle, a ray drawn from the centre to the circumference. Radiation, the emission of rays of light or of heat from a luminous or heated body. Radiolites, a genus of fossil shells, the inferior valve of which is in the shape of a reversed cone, the superior valve convex. Raft, trunks of trees and other vegetable debris matted together by natural causes and sunk in a river or stream. Rapilli, small volcanic cinders. Reaction, the force exerted by two bodies which act mutually on each other. Realgar, red sulphuret of arsenic, a compound of sulphur and arsenic. Refrigeration, the act of cooling. Resinous, containing resin. Retusus, Latin, retus, blunted. Revoluta, Latin, turned again. Rock, any mineral aggregate. Rodentia, from the Latin rodere, to gnaw, an order of mammals. Rodents, gnawers, animals of the order of Rodentia. Rostellaria, from the Latin rostellum, a little beak, a genus of univalve mollusks. Rothomagensis, Latin for Rothomagum, a temple of Roth, a divinity of that part of Gaul now called Normandy. Hence too the name of the city Rouen, belonging or relating to Rouen, specific name of an ammonite. Ratitodi ligente, German, new red sandstone. Rotata, Latin, rotate, wheel shaped. Rotundus, Latin, round. Rubble, angular and broken fragments of subjacent rock lying beneath the superficial mould. Rudistes, from the Latin rudis, unacquainted, because the characters of the animal were unknown. Name of a family of extinct mollusks, in the shells of which neither the hinge, the ligament of the valves, nor the muscle of attachment is discoverable. The family contains 6 genera: spherulite, radiolites, calceola, burostrites, Dicina, and Crania. Rugosa, Latin, rugos, wrinkled. Rugosity, a wrinkling. Ruminantia, order of mammals which chew the cud. Ruminants, animals that chew the cud. Saccharoid, from the Latin saccharum, sugar, and the Greek eidos, resemblance, resembling loaf sugar. Salamaniac, a compound of ammonia and hydrochloric acid, muriate of ammonia. Salt, any combination of an acid with a solidifiable substance. Sandalina, Latin, sandal-like. Sandstein, German, sandstone. Sandstone, any rock consisting of aggregated grains of sand. Saurians, from the Greek sauros, a lizard, animals of the lizard tribe. Sauroid, from the Greek sauros, a lizard, eidos, resemblance, resembling a lizard. Saxiogenous, from the Latin saxum, rock, and the Greek geonomy, I produce, rock producing, rock forming. Scabra, Latin, rough. Scaphites, from the Greek scaphe, a boat, the boat ammonite. Schist, German, from the Greek schistos, split, slate. Schistose, slaty. Scoriae, Latin, plural of scoria, dross, volcanic cinders, cinders and slags of basaltic lavas of a reddish brown and black colour. Scoriaceous, of the nature of scoriae. Scoriaform, in the form of scoriae. Seams, thin layers or strata interposed between others. Secreted, separated by the action of organs. Sediment, from the Latin sedeo, I sit, that which subsides or settles to the bottom of any liquid, dregs. Sedimentary, belonging or relating to sediment. Selenite, a variety of gypsum. Sella, Latin, a saddle. Semi-crystalline, partly crystalline. Sensibly, perceptibly. Sepia, a kind of paint or ink prepared from the cuttlefish. Septa, Latin, plural of septum. Septaria, flattened balls of stone which have been more or less cracked in different directions and cemented together by mineral matter which fills the fissures. Septum, Latin, a partition. Cereale, Latin, ceria, a jar, jar-like. Serpentine, a magnesian rock of various colours and often speckled like a serpent's back. It is generally dark green. Serpula, from the Latin serpo, I creep. A genus of annelidans which inhabit a calcareous tube, usually adherent to the shells of mollusks. Sessile, from the Latin sessilis, dwarf fish, without a pedicle or support. Shale, an indurated slaty clay or clay slate. Shingle, loose, water-worn gravel and pebbles. Singularia, from the Latin cingulum, a seal. Fossil plants found in the coal formation. Silex, from the Greek kalos, a pebble. The principal constituent of quartz, rock crystal, flint, and other siliceous minerals. Silica, silicious earth, the oxide of silicon, the elementary basis of silica, constituting almost the whole of silex or flint. It combines with many of the metallic oxides and is hence sometimes called silicic acid. Silicate, a compound of silicic acid and a base. Silicate of iron is a compound of silicic acid and oxide of iron. Plate glass and window glass are silicates of soda and potassa, and flint glass is a similar compound with a large addition of silicate of lead. Silicious, containing silica. Silicified, petrified or mineralized by silicious earth. Silt, the name given to the sand, clay, and earth which accumulate in running waters. Silurian system, series of rocks formerly known as the Greywacke series. Sinutata, Latin, hollow, excavated. Sinus, Latin, a hollow or excavation. Sinuosity, a hollow, an irregular winding excavation or hollow. Siphon, from the Greek siphon, a tube, a cylindrical canal perforating the partitions of multiocular shells. Siphuncle, a small siphon. Slate, a well-known rock which is divisible into thin plates or layers. Socialis, Latin, social, relating to companions. Solfatara, Italian, a volcanic vent emitting sulphur and sulphurous compounds. Solum, Latin, the sun. Spatongus, from the Greek spatogos, a species of Echinus, a genus of sea urchins having the mouth situated laterally, but 4 rows of pores. Species, a kind, a subdivision of genus. Specific weight or specific gravity, the relative weight of one body with that of another of equal volume. Sphenopterus, from the Greek sphen, a wedge, pteris, a fern, a genus of fossil plants. Sphenophyllates, from the Greek sphen, wedge, phullum, leaf, lithos, stone, a family of fossil plants. Spherolites, from the Greek sphaira, a sphere, lithos, a stone, a variety of obsidian or pearlstone which occurs in rounded grains. Spinosa, spinosum, Latin, spinous, covered with spines. Stalactites, from the Greek stalasso, a drop, conical concretions of carbonate of lime attached to the roofs of calcareous caverns, and formed by the gradual dropping of water holding the carbonate in solution. Stalagmites, stalactical formations of carbonate of lime found on the floors of calcareous caverns. Staurotide, from the Greek stauros, a cross, eidos, form, cross stone, prismatic garnet. It is very abundant in New England. Stellus, Latin, stars. Stigmaria, from the Greek stigma, an impression, a vegetable fossil. Strata, Latin, plural of stratum. Stratum, Latin, a layer, a bed. Stratification, an arrangement in beds or layers. Stratified, arrangement in strata. Striae, Latin, diminutive channels or creases. Striated, marked with striae. Strike, the direction of strata, the line of bearing. Sub, Latin, under. Subapennine, applied to a portion of the Pliocene strata, low hills which border the Apennines. Sublimation, the process by which volatile substances are raised by heat and again condensed into the solid form. The substances so obtained are called sublimates. Submarine, beneath the sea. Submerged, immersed or covered by water. Sublicata, Latin, somewhat plated. Substratum, an underlayer or bed. Sulcata, sulcatus, Latin, sulcate, grooved or furrowed. Sulfatization, the act of converting into compounds containing sulphur. Sulphuret, a compound of sulphur with another solid. Sulphuric, sulphurous, relating to sulphur, applied to acids composed of sulphur and oxygen. Superposed, from the Latin super, above, pano, I place, placed above. Syenite and sienite, a granitic rock from Sinai or Siena in Egypt. It consists of quartz, feldspar and hornblende. It is tougher than granite and a more durable building stone. Synclinal, from the Greek sun, with, klinine, to incline. Synclinal axis. Tabular, in form of a table, horizontal. Talc, a foliated magnesian mineral of an unctuous feel, often used for tracing lines of wood, cloth, etc., which are not so easily effaced as those of chalk. Talcose, of the nature of talc. Talus, a sloping heap of fragments accumulated at the foot of a steep rock. Temperature, a definite degree of sensible heat. Tendon, from the Greek teino, I stretch, a fibrous cord at the extremity of a muscle, by which the muscle is attached to the bone. Terebellum, from the Latin terebo, I bore, a genus of gastropod mollusks. Terminal, belonging to the end. Testaceous, from the Latin testa, a shell, consisting of carbonate of lime and animal matter. Testudinaria, a tribe of chelonian reptiles. Thermal, from the Greek therma, heat, warm, hot. Thermometer, from the Greek therma, heat, metron, measure, an instrument for measuring heat. Thin out, strata are said to thin out when they diminish in thickness. Tissue, from the Latin tela, a web or web-like structure constituting the elementary structures of animals and plants. Trachyte, from the Greek trachos, rough, a variety of lava, a feldspathic rock which often contains glassy feldspar and hornblende. When feldspar crystals are thickly and uniformly disseminated, it is called trachytic porphyry. Trap, from the Swedish trappa, a flight of stairs, because trap rocks frequently occur in large tabular masses, rising one above another like the successive steps of a staircase. Applied to certain igneous rocks composed of feldspar, augite and hornblende. Trappean, relating to trap rocks. Trapezoidal, in the form of a trapezium. Travertine, from the Italian travertino, limestone deposited from water holding carbonate of lime in solution. It is found in the sweet springs of Virginia and at the hot springs of the Washita in Arkansas, as well as in many other places. Tremolite, a mineral often of a fibrous structure, generally containing silica, magnesia and carbonate of lime, originally found in the valley of Tremola on St. Gothard. Trenchant, cutting. Trias, from the Latin tres, three. Triassic, of the nature of trias. Trigonalus, Latin, from the Greek trias, three, gona, angle, having three angles or corners. Trigonia, from the Greek trigonos, three cornered, a genus of bivalve mollusks, most of which are extinct. Trigonula, Latin, having three little angles. Trituration, from the Latin tritus, rubbed, the act of rubbing or grinding. Truncate, terminating very abruptly, as if a portion had been cut off. Truncatus, Latin, truncate. Tufa, Italian, a volcanic rock composed of an agglutination of fragmented scoriae. Turbo, Latin, a twisting, a genus of univalve gastropods. Turbinata, turbinatum, Latin, shaped like a top. Turriculated, resembling a tower with turrets. Turritella, Latin, a little tower or turret, a genus of gastropods. Undulation, a wave, arranged in a wave-like manner. Undulatus, Latin, waved, having a waved surface. Unilocular, from the Latin unus, one, loculus, partition, having but one chamber or compartment. Unio, Latin, a pearl, a genus of mussels. Uniones, plural of unio. Unstratified, not stratified. Uptilted, tilted up, raised at one end. Ursus, Latin, a bear. Varians, Latin, varying, changing. Vascular, containing numerous vessels. Vegetative life, life of nutrition. Venericardia, from Venus and cardium, a genus of bivalve mollusks. Ventricosa, Latin, ventricose, inflated, swelled in the middle. Vertebra, from the Latin vertere, to turn, a joint or bone of the spine. Vertebrae, plural of vertebra. Vertebral column, the spine or backbone. Vertebrate, having vertebrae or a spine. Vesicularis, Latin, vesicular, containing vesicles. Virgula, Latin, a little rod. Viridius, Latin, green. Vitreous, from the Latin vitrea, glass, resembling glass. Vitreoresinous, partaking of the nature of glass and resin. Volatile, from the Latin volo, I fly, capable of assuming the state of vapour and flying off. Volatise, to become volatile. Volcanic, relating to a volcano. Voltsia, a genus of fossil conifers. Voluta, Latin, a whirl, a genus of gastropods. Voscian, belonging or relating to the Vosges. Vulgarius, Latin, common. Walchia, a genus of fossil conifers. Weald, name of a part of Kent and Surrey in England. Whinstone, a Scotch name for greenstone and other trap rocks. Zamia, from the Greek zemia, loss or damage, a genus of the order of Cycadae plants. Zechstein, German, a magnesian limestone lying under the red sandstone. Zoophyte, from the Greek zoon, an animal, phuton, a plant animal which seemingly partakes of the properties of both plants and animals. End of glossary M through Z. End of Elements of Geology by William Ruschenberger.